What's going on, guys? This is Junior here, and today I'm going to show you how to build a RESTful API. And this course is geared towards beginners, so if you're a beginner and you're looking to up your skills, then this course is for you. And the first thing that I want to do is to give you an overview of what we're going to be covering in this course. And as you can see here, we're going to be using Spring Boot to build the REST API, and then we're going to be using Spring Data JPA so that we can connect to a data storage. So in part one, we're going to be covering all the different CRUD operations, as you can see here. So we're going to handle GET requests to request data from the server, POST requests to save new data, PUT requests to update existing data, and then delete requests to remove data from the server. And once we get the API up and running, we're going to move on to security, because if we build something, we have to make sure that it's secure so that only authenticated users with the correct permission can access the API. So we're going to be using Spring Security so that we can achieve this. And some of the features we're going to be covering include protecting API routes. So only unprotected route can be accessed by non-authenticated users. All the other routes in the application should be protected. And then we're going to give the functionality to create a new account, to log in with an existing account, and also control access to the resources using the roles of the users or the account. So this is going to be pretty interesting. And then finally, we're going to move on to deploying the application. So I'm going to show you how you can use Docker and show you how to run different containers using something called a Docker Compose file. And I'm going to show you how you can take both the Spring Boot application and your database configuration and combine those into one configuration for Docker. And then you can run that one configuration and it's going to spin up all the different containers you need for your Spring Boot application and also your data storage. So if that's Postgre or MySQL, and then we're going to deploy the application. And like I mentioned, this course is for beginners, but if you're intermediate level, this is a good course for you as well, because I'm going to take you from A to Z. So I'm going to show you how we're going to start by just understanding what an API is and how they work and why we use them, and then show you how we're going to build one. And then on top of that, show you how to secure it. So we're going to add Spring Security and then secure our API. And then finally, we're going to go ahead and deploy it. And this is just a high level. There's a lot more details that are included in the course. So without wasting any more time, let's go ahead and get started. Let's go ahead and bootstrap a Spring Boot application. And as you can see, I am on start.spring.io. And this is a website that you can use to quickly create a Spring Boot application. And I've already pre-filled some of the metadata information, as you can see here, because I didn't want you to see me type all this out. And at the top, we're going to be using Maven. It's a Java project, 2.74. The stable version is fine with me for Spring Boot. And our packaging is going to be a jar, and Java 17 is fine with me. Now let's go ahead and add the dependencies that we're going to need. So the first one I want to add is the web, because we're creating a web application. And I want to add the MySQL. So that's going to be the driver so that we can connect to MySQL. And I'm just using MySQL because that's what I have running. I have it actually running on the Docker container, but you can use Postgre or any other relational database. It should work the same with Spring Data JPA. The only difference is going to be in the configuration, and that's not going to be anything major. So I'm going to select MySQL, and I also need I want Lombok, and I also want validation. So validation. And also Spring Security. So I'm going to say security, and then I'm going to select Spring Security. And lastly, we need JPA. So I'm going to say JPA, and then select the Spring Data JPA. So I think that's all the dependencies that we're going to need. And I'm going to go ahead and click on generate and just save this zip file. So I'm going to go ahead and save this zip file, and then I'm going to come back and then open it up in IntelliJ after I unzip it. So let's go ahead and save. All right, so it's saved on my computer. Now let's take a look at what we have. So before we jump into writing any code or anything, it's really important that we take a look at what this is all about. And in this presentation, I'm going to see if I can give you the Spring Boot approach at a high level. And as you can see here, what we're going to try to do is to build the purple area. So we're going to be building the API that any application can communicate with. And you can see on the left here, I have a computer. So you can have an application running on the browser. So that could be your React.js application, or Angular or Vue, or just some plain old JavaScript application that you have running in the browser with some HTML, and then they can make requests to the backend, which is the API. And the same goes for the phone. So on your phone, you can have an app app or the browser open on your phone, that's an application, and it's calling the API application, because APIs are designed generally for other applications. They're not designed for humans to interact with. And that's what we have at the bottom here. You can see I'm trying to put a picture of some other applications that's calling the API itself. So that can be the terminal application, so that can be curl, or that can be HTTP, or it can be any application code that you can use to call the backend API. So really, either a user can do that through a browser, or the application itself can send the request. Maybe you have some processes that's running on the cron schedule, and every 3 hours, it makes a call to the API to retrieve some data, and then maybe send you an email or something like that, right? Run some report. It can be anything. So that's on the left here. And one of the most common ways that this is done is by using the HTTP protocol. And that's why you see that I put the HTTP protocol at the top. And if you remember from the overview that I gave you, you see that we have all the CRUD operations. And what's been done is they've been able to connect the HTTP verbs with the CRUD operations. So for example, to get information, so in the CRUD operation, that would be the read or the R in the word CRUD, then that would be the get request, because whenever you want to request data from the server and you're using the HTTP protocol, then you send a get request to the server. And then to create data on the server, which is the C in the CRUD, then that would be a post request. And then a put request for the update, and that would be the U. And then to delete in the CRUD, so that's the D. Then there's also an HTTP method called the delete method. So we have a get to read the data, we have the post to save the data or to create data, and then we have the delete. That's for deleting data. So that's the D in both the HTTP protocol and also in CRUD. So the D in the word CRUD. And then update, which is the U in the word CRUD, that would be the put. So an HTTP put request. The request method is the put type. So that's just the connection. But for right now, what I want you to understand is at a high level, the architecture of an API, or most API, or at least the Spring Boot APIs that people usually build. And you can see we're going to have a bunch of resources. So the resources, they're going to be the actual APIs. And what that means is that that's the programming interface. So that's the interface that is exposed that can receive HTTP requests. Everything else is hidden under the application. The external doesn't have access to anything else except the API. So in the resource layer, which is going to be the API, that's when we're going to be waiting for requests, HTTP requests to come in. So the get request, the put request, the delete request, and the update request. So that's handled in the resource or the API. And then the API or the resource is going to make a call to the service. Now the service is where you're going to have your business logic, and the service can have multiple implementations of itself. So the service in itself is a contract. So it says, hey, this is what needs to be done, but there's no implementation for it. And what that means is that the service only says, hey, this is what needs to be done, but it doesn't say how it should be done. And this is all going to make sense when we start diving into the code. So the service is a contract. It's like a specification. It says, hey, this is what needs to be done. The application should be able to handle all of these different events or all of these different functionalities. And the implementation is where you're going to say, okay, so I want to create a user. I know the service says the application should be able to create a user, but this is how we're going to do it. Are we going to call a MySQL database to save the user? Are we going to call a Postgre database to save the user? Are we going to call a NoSQL database to save the user? Are we going to call DynamoDB on AWS to save the user? Are we going to just save the user in a file on the system? So that's where the actual implementation of the different specifications of the service take place. That's in the implementation. And a single service can have different implementations. So you can see here, I put service implementation 1, service implementation 2. We can have multiple different implementations of the same service. And the implementation of the service usually communicate with a persistent layer. And that's where you're going to have other logic that pertain to the persistence. For example, if I'm going to save a user, before I save the user, I may check to see if the email is unique. So I may make a call to the database with the email that they're giving me and make sure that I don't already have a user with that email. It depends on the business logic, and I'm just taking this as an example. So that's going to be where you're going to handle that. That's going to be in your persistence layer. And the persistence layer also is a contract. So the persistent layer can say, hey, we want to be able to update a user and they should give us this type of information, but it doesn't say how it should be done. And it's in the DAO implementations, that's where you're going to specify, okay, we know that we have to update this specific user. That's a functionality that the application has. And this is how we're going to do it. This is where you're going to actually implement that specific requirement. And DAO here stands for data access object. And it's really just separating everything into different layers because we don't want to put everything all together. We want to make sure that this is maintainable and it's decoupled. So we have different layers that are responsible to do different things. And the DAO implementation, or the DAO, that's what's going to be communicating with the storage. And here I put RDMS, which is Relational Database Management System, but it doesn't have to be a relational database. It can be a NoSQL database like DynamoDB or MongoDB. But in our situation, we're going to be using Relational Database Management System. Those are relational databases with tables and relationships between these tables. So as we go through the course, you have to make sure that you keep this image in mind, because at every stage, we're going to be building one of these. And it really doesn't matter which one you start with first. However, in a lot of cases, they're going to start with the RDBS design first. And this is usually for complex applications, because if we're going to have a very complicated applications with a lot of different models and a lot of different logic, then we want to make sure that we're designing it properly and we don't rush anything. In situations like this, there's usually a designer, like a database management system designer, and they would start designing the application after gathering all of the business requirements from the business people. So this is just overall information that I'm giving you so that you understand where this is all coming from and why we're going to be doing it this way, because we don't really need to have a business layer and a persistence layer. We can put everything inside of the resource, but that's a terrible idea, because then it's not maintainable and it's not expendable. It's just going to be a whole big mess, and you don't want to do that. And also remember, this is just a very high level of this architecture. The service layer can also have other services that it calls. For example, you might say, hey, whenever a user creates an account, let's say we're going to save a new user, for example, and I'm just using user as an example. I'm just taking users as an entity. So say we're going to save users. Maybe we're going to ask them for their phone number. So in the business layer, we might say, hey, maybe we should call to an external API. Maybe we need to send a request to AT&T so that AT&T can send a text message to the user and ask them to confirm their account or confirm their phone number. So that means that the business layer itself can call to other services. But since this is a beginner-friendly course, I don't want to overwhelm you with all the different things that can happen in all these different layers. But just understand that the business layer and the persistence layer, or the persistence logic or the business logic layer, they can also call other services and other databases. For example, you see here I put RDBS, which is one database, but the DAO implementation can call to different storage in different places. And then you might be wondering, well, why we have to do all that? Why can't we just handle everything in our own application? Well, this is also a terrible idea, because you want to be able to externalize different applications because it's cheaper, or maybe it's faster, or maybe it's safer, or maybe because you don't want to deal with that, you would rather delegate that specific functionality to an existing service or an existing provider that already has an entire architecture for this that even your customers are already using. And maybe it's going to cost you so much money, and it's just not worth it, because for the money that you're going to spend to build this entire thing, it's just not going to cut it for you, because you're just not going to make the money back if you were to do that. So there's like thousands of reasons why you might choose to externalize different functionalities. It's just better and easier and a lot cheaper and less time consuming to just dedicate this specific functionality to an external provider. And I can go on, but I'm just going to stop here because this thing can get really complicated. And like I said, this is for beginners, but just understand what you're getting into. So if you're trying to be a developer, you're trying to be a full stack developer or a backend developer, then you know that you're going to be dealing with very complicated situations and you're going to have to make the best decisions for yourself. So keep this image in mind, and it's really important that you do this, because everything you're going to learn, you really want to take a good 5 to 10 minutes and understand what you're trying to do, and not just jump into the code or jump right into practice. You want to understand what you're trying to do, what are the different components, how they fit together, and then you can start building your application. So now that we understand what we're going to try to do, let's go ahead and dive right into it. I have the application open in IntelliJ, and I'm just going to check the main class here. Okay, so that's a typical Spring Boot application. And the first thing that I want to do is to define the service. So we're not going to create the REST controller yet. We're just going to define the service so that we can define what we want the application to be able to do. So I'm going to go in here and then create a new package. I'm going to call it service. Okay. And then in here, I'm going to create the first class, and I'm going to call it employee service. Okay, so I'm choosing to work with employee in this example, but you can work with users, students, any entity that you like. So in this service, we're going to go ahead and define all of the different specifications that we want to have in the application. So I'm going to go full screen here so that you're not distracted by all the statistics that you see at the top of my screen. And what I want to do before I actually define these specifications is to put some comments for myself, right? So I want to say, I want to be able to save an employee, right? So that's one of the things that we want this application to be able to do. We want to be able to take an employee information and then save it somewhere. And then the second thing we want to be able to do is to get employees, right? So we might want to return a list of all the employees that we have in the application. Also get one employee, okay? In case we want to see just one employee. And then we want to be able to update an employee. So update employee and then delete employee. So those are the functionalities that we want to be able to define in this specific application. Obviously, this is really basic, but I just want to show you an example of how this can work. Now, before we can define the specifications or the methods that we're going to define in here, I want to define what an employee is, right? Because right now it's abstract. We don't know what that is. So let's go ahead and create a domain. And I'm going to create a domain package. You can call this domain or you can call it model. I'm going to call it model. And here we're going to define the employee. So right click again, new Java class, and then we're going to say employee. So in this class, I want to define a few things. So these are going to be the parameters that I want to have on any instance of the employee. So really just defining what an employee should look like. So I'm going to do private integer, and I'm going to define an ID for the employee. This is actually really important because it's going to serve as a unique identifier for every single employee that we have. And then I'm going to define a string that's going to be the first name of the employee, and define the last name. So another string for the last name for the employee. And then lastly, I'm going to give them a username. Okay, so every employee is going to have a username. And since we have Lombok, so I'm going to go ahead and add some annotation here. So we need getter and we need setter. And we need some constructors. So I'm going to say all args constructor and then no args constructor, right? So we've added constructor for this entity and we've also added getters and setters. So now we have defined what we want an employee to look like. So employees are going to have an ID, a first name, a last name, and a username. Now we can go ahead and work on this service. So remember, the service is where we're going to define what we want the application to be able to do. And you know, we want it to be able to save an employee, get employees, get one employee, update an employee, and delete an employee. So that's what we're going to be working on next. So for the service, we know we're going to need to be able to save an employee. So I'm going to create a function here or a method. I'm going to call it add employee. And it's going to take the employee that we're trying to add. So I'm going to pass in here employee coming from our domain, and that's going to be the employee. So we're defining the specification for this. And also this is supposed to be an interface and not a class. So I'm going to go ahead and change that. So we're defining the employee service, which is a specification. And we're saying that the service should be able to save an employee or add an employee to our database or our data store. And it's supposed to take the employee that we're trying to add. So that's going to be for saving an employee. Now to get all of the employees, we're going to return a list. And that's going to be a list of employees. And I'm going to call it get all employees. And this doesn't take any parameters because we don't need anything from the user. They don't need to give us anything. If they call the get all employees, then we return all of the employees for them. In most application, or I should say in most real world applications, you would never try to return every employee, for example, that you have in a database unless you were certain that you would never have maybe like a couple hundred employees. But if you're building a real world application, then you got to make sure that you paginate this because you don't want to return like 10,000 records to any customers. They're just not going to be able to manage all this data. It's going to be overwhelming. They won't be able to make sense of it. So that's something that you should keep in mind, anytime you try to read all of your records in your database, make sure you paginate it. Make sure you put the data into different pages, and then you serve a number of pages at a time. And I'm gonna go ahead and import the list here. So import class, that's coming from Java util. And to get one employee, I'm gonna return an employee because we're trying to get an employee. And I'm just gonna call this one find maybe by ID, right? Because we need the primary key or the identifier so that we can look for that specific employee in our data store. And then to update an employee, so we can do something similar to the add. I'm gonna copy this here and then paste it here. And this is gonna be update the employee, and then they can give us the employee information. So that's going to be an existing employee, because if they don't exist yet, then we can update them. And then lastly, to delete an employee, I'm going to make this return maybe a Boolean, and then I'm going to call it delete by ID, for example, because we need the ID again in order to be able to delete the user. So the integer is just going to be the ID. So these are the specifications that we have in the service. And as you can see here, we're just defining these methods, but nothing is implemented. And this service now can be implemented many different times. So there can be like 5 or 6 or 7 implementations of that one service. And I'm going to show you an example of this. I'm going to show you an example of having many different implementation of the same specifications from a service. So that's what we have to define in the service. And what we're going to be doing next is to create some kind of repository that any implementation of that service can use so that they can implement all of these specifications. So before I create any implementation of the service, I want to create the DAO that can be used for one of these implementations or many of these implementations. In JPA world, this is called a repository, but it's actually the DAO, the data access object. So I'm going to go ahead and create a new package, and I'm just going to call it repository. So we're going to say repository, and then press enter. And what I'm going to do here is to define one implementation of a DAO, which means how the data is actually going to be saved and how it's going to be retrieved. So right now I'm going to go ahead and right click and then do new, and I want to do a Java class, and I'm going to call this in memory employee repository. So this is going to save all of the employees in memory. So we're not going to be dealing with any database or anything like that, because I just want to show you how we're going to gradually go from in memory and into a database management system so that you can really understand all of these different concepts that we went over in the presentation. So here I'm going to define private, let's do static final, and I'm going to define a list of employees. So that's going to hold all of my employees. So you can consider this our database. And then I'm going to call it, actually, I'm going to call it database, right? So that's a database where all of the employees are going to be. And then I'm going to define it as a new array list, right? So I'm going to say new array list, okay? So that's what we're defining here. This is going to be our database, and I need to import the list. All right, so that's our in-memory employee repository. And I'm also going to annotate this with a repository because that's what it is. Okay, so that's how Spring create beans that are of type repository. Repository meaning the data access object or the database or the persistence layer. So that's our database. And then what I want to do is to create a static block. So I'm going to do static. And the reason that I'm using a static block is because I want to initialize some employees, because right now we have the database, but it's empty. So I'm going to go in here and then call our database and then add some employees. So I'm going to say add, and then we're going to add some employees. So here we're going to say new employee. So call the constructor, and then I can pass 1 for the ID, and then for the name, I'm going to pass John. And for the last name, I'm going to go ahead and pass maybe Smith. And then we're going to give him a username. Maybe we should make this an email. So let's do john@gmail.com. I feel like an email would make more sense. So let's go back to the employee. And for this, we're going to just name it email. It's the same thing because it's still going to be a string. So it doesn't really matter here. And then we can come back here and then define this as an email. Okay, so you can see IntelliJ is picking it up as an email. And then we're going to put semicolon. So I'm going to define maybe 3 employees just to start with. So I'm going to paste this twice. Oops. and I'm going to collapse this for more room. So now we're going to have these 3 employees, and I'm just going to change this to maybe Alex, and change the last name to just something different. And then here I'm going to pass in Alex. So Alex. Oh, we need also to change the ID. Let's change that to 2. Change that ID to 3. And we can make this maybe David. And let's make the last name Cameroon or Cameron. I don't know. And then we're going to say david@gmail.com. Okay. So now we have our database. Okay, so this is where the data is, where the data lives, which is in memory. So now remember, we're defining this repository so that it can be used by an implementation of this service, right? Which means that we also have to provide all of these different functionalities so that whatever employee service implementation that is implementing this service can have access to the same functionalities, right? Otherwise, how are they going to be able to do this? So I'm going to go ahead and just copy everything here and then go over to the employee repository. And then here, I'm going to paste everything. Now, remember, we have to actually give the implementation for this. So I'm going to remove this comment. And I'm going to go ahead and remove this semicolon because now we need to actually implement these methods. And then I'm going to go in here. I'm going to say, well, if someone is trying to add a new employee, all I got to do is call my database and then add that employee to my list of employees that I'm keeping. And then we're going to pass it in here and then semicolon. Okay, so this is an actual implementation from the repository or from the data access object that we're giving here. And then we're going to do something similar here. So if someone is trying to get a list of all of the employees, what we can do is to just return maybe a copy of our list. So we're going to say list, copy of, and then we pass in the database. Okay, so we're going to give them a copy of whatever we currently have in the database. And also remove this comment because we don't need it. And then to find by ID, that's going to be pretty straightforward. We're going to give the implementation as well. So here I'm going to do return. So return, we're going to call our database, and maybe we can stream because we need to look for something in there, and we're gonna filter by let's do filter. So when we're gonna stream and filter, we're gonna go through every single one of them. So we're gonna say for every employee, what we want to do is to find the one that matches the ID. So we're gonna say the ID that we get, we're gonna check to see if it equals the employee in the current iteration that get ID. Okay, so we're comparing to see if we can find someone that matches this ID or their ID matches this, right? So whatever employee that's in this database, when we're going through the stream and we're filtering by the one or that one employee whose ID matches the ID that we're getting here. And then we can say find first. So whatever we find, the first one, we're just gonna grab it. And then if we can't find anything, we can just throw an exception. So we're gonna say or else throw, and that's just gonna throw an exception. So that's all we have to do. So this is gonna go ahead and look through the database and then find the one employee that matches this ID, and then it's gonna return it. And then for the update, we're gonna do something similar, but what I'm gonna do is to leave this for you as your assignment. So we're gonna say assignment. Okay, so I get a lot of questions a lot of times where students are asking me, I do everything for them. So in this case, every time I'm implementing something, I will leave a little bit of homework for you guys to do. And of course, feel free to ask me any questions that you have. So this is for you to implement in whatever way that you see fit. So that's your assignment. And then for the delete, I will actually implement that one. We can do something similar. So let's just copy this and we're gonna paste it here. So in this case, we're just gonna try to find that employee. So we're gonna say employee and then try to find that employee and set it equal to that. So we're gonna try to find the employee, and then at the bottom here, we can call our database and say just remove that one employee that we just found, because we're trying to remove the employee, and then after that we can just return true. Okay, we're gonna return true here because this is returning a boolean. So if this operation is successful, then we're gonna return true. Otherwise we will get a failure or something like that. And I can do a static import for this true here. All right, so we're going to return true. So this is the in-memory implementation for the in-memory employee repository. So now whatever implementation of this service, if they want, they can use this specific implementation of the repository. Because remember, here in the service, we have the specification. The service implementation can have other business logic, but they're not going to be doing the actual persistence, like the saving in the database. That's the job of the DAO or the repository. And that's what we're doing here. We're defining the database, we're creating some employees to begin with, and then we're giving the actual implementation of how we want to do every single one of these. And I name this in-memory repository because I want you to see the difference, since we're going to have more than one. And I'm going to show you how we're going to switch from using one and using the other in the same application. Now that we have the in-memory employee repository, or DAO, we can go ahead and create an implementation of that particular service. So the employee service, we can actually give it an implementation. So inside of the, let's go to the service folder. So inside of the service folder, I'm going to create another folder, and then I'm going to call it IMPL for implementation. And in here, I'm going to create the implementation of the service. So I'm going to say in-memory employee service IMPL. Okay, so that's the in-memory implementation of that particular service. And in here, we're going to implement the employee service. So we're going to say employee service. Okay, so once we implement the employee service, now we're forced to define all of the different specifications or methods that are abstract inside of the employee repository, because now we have to give them an actual implementation. So we're going to select everything here, click OK. All right, so everything is generated. And I'm going to collapse this and do Control F here for full screen. So now we can bring in the in-memory repository, because in-memory repository give us some kind of database or persistence where we can actually have all of these different functionalities that we need. So we can go in here, and then we're going to do something called dependency injection. So here I'm going to say, well, give me an instance of that in-memory repository. So I'm going to say private, final, and then I'm going to say in-memory employee service repository, and then I'm going to give it a similar name. I can either do the dependency injection in the constructor, like explicitly, or I can just pass in an annotation here. So here I'm going to say required Rx constructor. Okay, so that's going to create a constructor for us, and then it's going to pass in this argument or this field inside of the constructor so that we don't have to do it explicitly. And also we need to define this as an actual service. So we're going to say service. All right, so that Spring can pick it up as a bean. Now we can make use of this repository and then give functionalities or implementation for the methods or specification that we had in the employee service. And also this would be the place where you would add other business logic if you had any, but in our case we don't really have any other business logic. We're just gonna go ahead and call the method inside of the employee repository directly and then pass in the values that we need to pass. So I'm gonna say if we're trying to save an employee, then just call the employee repository and then call the add on that. But there is one thing we need to do that I just realized. We won't be able to use these methods because we have to make them public. So let's go ahead here and make all of this public so that we can be accessed outside of this class. Okay. All right, so now if you come back here and we press that, we should be able to use all of these different methods. So here we're going to pass in the employee. Okay, so we're going to call in the in-memory repository. That's going to save the data in memory and then give it the employee. And we're going to do something similar for everything else. So here we're going to return the repository and get all employees, because that's what we're trying to do here. And then for the find by ID, again, pretty simple. We're going to call find by ID and then pass in the ID. And then for the update, that's your homework again. So I'm just going to go ahead and add a comment here. Assignment. So go ahead and do that one, and you can share a solution with me and I can take a look at it. And then the last one, again, pretty simple. We're going to call the delete, pass in the ID. Okay, so we're giving implementation for the specification and the service. And of course, everything is straightforward because we don't have any other business logic or anything like that. All right, so now at this point, we're ready to expose an API or an application programming interface that's going to be waiting for incoming HTTP requests. Because now we can take those requests and then process them by just calling our service, and our service has an implementation, which is the in-memory service implementation here. That's using the in-memory repository. Okay, so I hope everything is connecting, and the next thing we're going to do is to expose our first API. So let's go ahead and work on that next. I'm going to go ahead and close everything here. So close all tabs, and I'm going to collapse this service. Now I'm going to go ahead and create the controller. So let's go here, create a new package, and I'm just going to call it resource. Okay, so that's where we're going to serve all of the resources in this folder right here. The first resource that I'm going to have is the one to expose the employees. So I'm going to say employee resource. Okay, so an appropriate name. And to turn this into a controller or a REST controller, we're going to annotate it with REST controller. Okay. And then we can give it a request mapping so that we can set everything under a specific path. So here I'm going to say request mapping, and then for the path, not the params, we want the path. The path is the default, by the way, so you can just pass in a string here. I just like to pass it in explicitly. So for the path, we're going to set it equal to / maybe API / employee. Okay, so that's going to be employees with an S. So all the employee resources are going to live under this class. Okay, so now what I want to do is to pass in the service. So we're going to say private final employee service. It's going to be the employee service here, and then employee service. Okay, and then we're going to do something similar. So we're going to pass in the required our constructor. Okay, so that we don't have to define a constructor ourselves. Lombok is going to take care of doing that for us. So now we have the employee service inside of the API or inside of the resource, and the resource is going to be waiting for incoming requests. So now all we have to do is to intercept all these different requests and then call the appropriate service depending on the path and the request method and other things. So I'm going to go down, and then we're going to look for a get mapping. So let's do get mapping. And this get mapping is just going to go to /API /employees. So we don't have to pass in anything else. And then here I'm going to define a public method, and that's going to return something called a response entity. Okay, so this is a convenient class that is provided by Spring that you can use to return HTTP response, and it's widely used when you're creating resource. So I'm going to use it, and then let's pass in a list of employees. So that's going to be the method that's going to be waiting for an incoming request that is asking to get the list of all of the employees. So we're going to pass in here. The type of the list is going to be employee, and let's collapse these, and we can give it a name, for example, get employees, right? So that's the name of the method, and it doesn't take any parameters. And in here, what we can do is to return that response. So we can just return the response entity, and it also has very convenient methods. So in this case, we're going to pass in OK because we want to send back a 200, and then we're going to call the employee service and then get all employees. Okay, so that's going to return a list of all the employees. Also pay attention to what you're returning here, because whatever the body of the request is going to be, that's the type that you have to pass in here. So technically what we're saying is in the body of the response entity, which is just going to be an HTTP response, we're going to have a list of employees. And whenever you're passing in that body in the return statement, you got to make sure that whatever you're calling, or either a service or whatever the case might be, then it matches the same type. As you can see, I'm hovering over this, you can see the get all employees, it's returning a list of employees. So for this particular endpoint, we just have to go to the domain of the server. So since I'm running this on my local machine, that's going to be localhost, and then go to API and then go to employees. And if it's a get request, then it should land inside of this method, and it's going to execute this line and then return the response. So that's what we're doing here. And then at this point, it's only going to be a rinse and repeat. We're going to do something similar for the other functionalities. So I'm going to copy this and then paste it down a few times. So we have one to get all of the employees. Now let's change this to, well, I have a typo here. That's supposed to be E. And then here we want to get one employee. So we're going to change that to get employee. And this is also going to be a get request, but this time we need to get the ID. So we're going to pass in the ID here as a path variable. So inside of double quote, we're going to pass in the ID, which means that we're going to be expecting a parameter in the URL that's going to be the ID of the user. And then one way we can get this path variable, we're going to give it the name that we're expecting. So here we're going to pass in the ID. So this has to match whatever we pass in here. And then we're going to give it the type that we're expecting. So integer, and then we're going to call it the ID. And again, this is returning just one employee and not a list of employee in the body. And then here we're going to call get employee, or I think we name it find by ID, and then we pass in the ID. So this is a get mapping. This is also a get mapping. The only difference is this is taking an ID and this doesn't. And for the next one, we can do the add employee. So we're going to say add employee or save employee, and we need to get the request body, and Spring has another annotation called add request body. So we're going to say request body. And and then we're gonna say it's gonna be of type employee. So we're gonna pass in the employee and then employee. And now we're gonna call the add employee. So the add employee, I remember it's returning void. Let me copy this and let's go back in here. So typically when you save a resource on the server, you typically get this resource back. So let's go ahead and change that to make sure that it returns an employee. Now we also have to change the implementation. So let's copy this again and go and do the implementation. And here we're gonna make sure that this is gonna be returning the employee. And of course, we're gonna get an error here because now the actual DAO is not returning that. So first of all, we're gonna say, well, we gotta return that. And then inside of this, we're gonna make sure that we return the employee. So we're gonna go down here and then say return and then return that employee. So after we save the employee, as you can see here, we're going to return the employee. Okay, so typically that's what you would see whenever you save some data on the server, then you get this data returned back to you so that you know that it was saved. So make sure you make this change and let's go back here, move this, and now we can say, hey, when we're going to add an employee, it's going to return the employee. But now we have another problem because whenever we're going to create an employee, we need to give it a unique ID. Because if we go back into our repository here, you can see that they must have a unique identifier, which is the ID. Otherwise, this is going to break our application because we don't want multiple employees to have the same ID. All the IDs should be unique. Okay, so this is something that we just made up that just makes sense in our situation. And remember, this is in memory, so I can't just say, hey, the database is going to do it for me automatically. I'm just going to do auto increment or something like that because that's not a database. So that means that I have to handle this myself, okay, because I'm creating this database myself. So let's go back to the resource, and what I want to do is I'm just going to go down here, and before I save the employee, I want to set the ID on the employee. So I'm going to call the employee and then set ID. And what I want to do is call the employee service, okay, and then get all the employees. So we're going to get all of the employees that we have in a database and then look at the size of the list. That's going to give us how many we have in a database. And then we can just add 1 to this. Okay, so the ID is going to be a +1. So that's a little workaround that we are doing here just to make sure that the ID is always unique. Okay, so there are many different ways to do this. But since I want to show you the in-memory and then I'm going to show you something that is going to be stored in a database, I'm just doing this quick example here. And I'm going to show you that everything is going to work the same. So once we build this, we're never going to come back here again. All we're going to change is not the service, but the implementation, which is going to be this guy right here. Okay, so that's all we have to change. And then we just point the service to this specific implementation. And that's all we have to do, because everything that implements this service, they must adhere to this specific contract, because that's what we're defining. Okay, so, and this is going to make sense in a minute. Let's go back to the employee resource. And I think we're good here. One last thing we have to change. We have to change the response code that we're returning, because here we're returning OK, which is a 200. Also here we're returning OK, which is a 200. But here we can return OK, but it's better if we return created. Okay, the created itself is the 201. That's what you typically send whenever you create a new resource on the server. And this takes a location that's going to determine the location of the resource that just got created. And then we can pass in the body, and the body is where we're going to do all of this. Okay, so now we have to pass in the location, because this create, if we go inside of it, you can see here it takes a URI location. Okay, so we have to pass that in. And I'm just gonna go ahead and create a method here. So I'm gonna say maybe get location, and we can give it maybe the ID of the employee. So we're gonna say employee that get ID, because that's the unique identifier, which is what we're using here if we're trying to get one employee. So that's what I'm passing here for the location. The location is going to be in the header. So let's go ahead and create this method down there. And all we have to do here, can return maybe servlet, I think it's servlet URI component builder. Yep, that's the one. And then we can do from current requests, and we can pass in maybe a path. So here we're gonna say that path, and we can pass in the ID. So we're gonna say that's gonna take an ID. So we're gonna say the ID of the employee, and then we can say build and expand. Oops. and we want that one, and we can pass in the ID and then call to URI, and that's all we have to do. Okay, so that's gonna just create a path for us from the current request and then pass in the ID, as you can see I'm doing here. And I'm gonna show you what that looks like whenever we create a new employee and then we check the headers. And I'm gonna do a static import for this. All right, and we can get rid of this one at the bottom because we don't need it. Okay, so this is gonna be our controller, and we have to change this to a post request. So that's gonna be post mapping. Okay, the request method is supposed to be a post, and now that I'm remembering, we have to do the delete. So that's gonna be the delete employee. So the delete mapping, again, the delete mapping is gonna take the ID of the employee that we're trying to delete. So I'm gonna copy this, paste it in here. We're gonna do this again. And we're gonna call this delete employee, and we don't need to do this. And we need to pass in 200, and we're gonna pass in the employee service that delete, and then give it the ID. Okay, and then here this is a boolean. Okay, and I'm gonna do the update, well, not all the way, but just so you remember, I'm gonna pass in date employee. Okay, and I'm gonna let you figure that out, and I'm gonna make this return null. That's the assignment. Okay, so this is the one that we're gonna have here, and I'm just gonna fix this for you. This is gonna be a put. Okay, so put mapping for updating information. I don't know if it's gonna take an ID or not. I'll let you figure that out. All right, so this is for you guys to do as practice. So now I think we're ready. Everything should be in place. We can go ahead and start the application and then hit this endpoint. We should be able to see something, at least the 3 employees that we know we have inside of our in-memory database. So that's what we're gonna be doing next. We're gonna see if we can test this application. Now we're ready to go ahead and test the application. And if you look at the top left corner, I have 2 more workspaces open. I have a second one with my terminal, and then I have a third one with Postman. So we're gonna be using Postman in another application called HTTP so that we can make requests to the application. So let's go back here, and there's a couple things that we need to do. So I'm gonna open the POM file and just gonna collapse this for now. So what we're gonna do is to comment out the security because it's gonna stop us from doing anything because we don't have any configuration for it yet. And also I want to remove the MySQL connector because it's gonna try to find a configuration for a database, and I haven't put that in yet, so it's gonna fail, and we don't want that to happen. So I'm gonna temporarily comment out all of these, so the MySQL connector and also the security, so that they don't take any effect. And the other one we have to comment out is the Spring Data JPA, so let's comment that out and reload. So clicking this M here, that should reload everything. Okay, everything seems to be working fine. So I'm gonna take it for a spin, so I'm gonna go ahead and run it. Okay, it's coming up. All right, so it's running, and you can see here it's running on 8080, so that's the port by default. So let's go back to Postman first, and I'm gonna create a new request, and here I wanna go to localhost 8080, and we wanna go to API/employees. So we're gonna say employees, and that's a GET request. So I'm gonna go ahead and send this request, and I misspell employees, so that's ES, and send it again. You can see we got the 3 that we added in memory. Okay, so you can see we don't have any JPA repository. We're not using an entity annotation, and everything is working fine. That's because I want to really make you understand from a conceptual level how this thing works, right? And then we're gonna move on to JPA repository and configuring our database and everything. But you can see all of these functionalities should be working. So the GET request is working. I'm gonna right click and duplicate this tab. And then now I'm gonna go to /1. Okay, remember that should give us the first employee. In this case, that's gonna be John here. So let's go ahead and send this request again. You can see we get John. Okay, and let's duplicate this one more time. Now I'm gonna send a post request. I'm gonna remove the 1. It's just gonna go to employees, and just so that I can save some time, I'm just gonna go ahead and copy this, and in the body we're gonna pass in some JSON data. Yeah, paste this in here. We don't need the ID parameter, so we're gonna remove that. And let's just give this person a different name. So let's do Joseph, and let's do Robinson, for example. And here we're gonna change this to Joseph. Okay, so if we send this request, everything should be saved in the database. So let's go ahead and send it. You can see the ID is 4 and Joseph is saved in the database. Well, it's in memory, but you know what I mean. And let's do Joseph 2 and send this request again. Next ID is 5, so we know that it was saved in our in-memory database. Okay, so everything seems to be working. And of course, if I restart the application, these users that are saved, they're gonna be lost because everything is saved in memory. Once the application stops, then the random access memory is gonna be destroyed. And that's just how RIM works. That has nothing to do with the application. So that's one application that we can use to test our API. And in my other workspace here, in workspace 2, I have my terminal open, and that's because I want to show you another application called HTTP. So if I do HTTP, because I already have it installed, I can pass in the 8080, so that's the port number, and I can pass in API /employees. Not gonna misspell it this time. And if I don't pass any domain, it's gonna use localhost. So if I send this, you can see we have the same data. Okay, so you can see we have all of the employees and the ones that we added as well. So the ID4 and ID5. Okay, and if I clear the screen, bring that comment back, and then pass in maybe 5, so that's gonna give me the last one that I just added. And if I press enter here, you can see we have Joseph with ID5. Okay, so everything seems to be working as expected. So our API is working. Now, what we have to do next? What do we have to do next? Well, the first thing is we're saving all of these users in memory, which is not good, right? We want to be able to save every user in some kind of persistent system, which is probably going to be a database or maybe a file system. But in our case, we're going to be using a database because we have JPA and MySQL. And I already told you that I have MySQL running on my computer. Well, it's running in a container on Docker on a local machine that I have on my network. It's not running on my computer, but it is the same thing. But that's what I'm going to use to persist the employees. So that's what I'm going to show you how to do next. So we know that our API is working because we just tested it and we saw that all the functionalities are working. But again, everything is in memory and that's not very good. So what we're going to try to do is to save everything in a database. And we're going to use MySQL to do that with the help of JPA Repository. So if we're going to use JPA Repository, what we have to do is we have to go inside of the domain class and turn this into an entity. Okay, you can see I have getters and setters and constructors, but I don't have this as an entity. And if we want JPA to manage this entity for us, then we have to define this as an entity. So let's go down here and we're gonna say add entity. Well, first of all, we need to uncomment on these lines. And well, not the Spring Security, we're not gonna do that just yet, but the JPA repository, so Spring Data. And then we need to enable the connector for MySQL so that we can connect to the database. Okay, and then reload. All right, everything is in sync. We can close that for now and go back to the employee. And then we're going to say entity. Okay, so you can see it's coming from Java persistence. So we're going to turn this into an entity. Now, once we do this, we need to tell JPA what the primary key is going to be. And we do that by just passing in the add ID and also the generated value. So we're going to say add generated value, okay, from Java persistence. And that's all we have to do. So JPA is going to pick this up as an entity and it's going to create a table for this class inside of the database configuration that we give it. And that's just object relational mapping. So that's ORM. It's technically Spring doing all the heavy lifting for us so that we don't have to do it ourselves. It's going to take this and map it into a table inside of our database or whatever database configuration that we tell it. So that is step one. Now the second thing we have to do, if you remember, we need to give it some kind of repository. Okay, so we know JPA is going to take this and just create the table and put this data in there. So it's going to put the ID, first name, last name, email. But that's just the table. But we need to have a way to manipulate the data inside of these tables. Whenever we're going to do persistence or manipulation of the data in the storage, we're talking about a repository. So we have to come back here. And what I'm going to do is to just create another class or an interface in this case. And I'm going to call it JPA employee repository. And JPA makes it very convenient. You can just extend the JPA repository and then give it the type of the data that you're trying to manage. So that's going to be the employee, and then the type of the primary key. In our case, that's an integer. And here we're going to do the same thing. So we're going to say add repository. Okay, we don't necessarily have to do that. It will still work, but I just want you to keep all these things in mind. So I'm explicitly putting the add repository here so that you know what it is, but this is not required. It'll still work. So now that we have this repository that's extending this class, JPA repository, and like I mentioned, JPA repository makes it very convenient to do the basic CRUD operations and more. So if we go in there, you can see they have a find all that's going to return a list of whatever the data type is. They have a save. So if we scroll down here, you can see they have a save all. They have a get one, get by ID, find all. So they pretty much have everything that we implemented ourselves already defined here, so we don't have to do it again. So I'm going to close out of this, and we really don't have to do anything here. We can just leave this here and then use the methods that I just showed you inside of the JPA repository. But if we wanted, we could define more in here. So we could define more methods in here and then give them the implementation. More if wanted. Okay, if need be. Okay, so if you want, you can define more here and then give the specifications for them. But for our situation, we already have all of the functionalities implemented for us in the JPA repository, so we don't have to define them again. So now we have a way to give another implementation for that service that's going to be using this JPA or DAO or persistence layer, which is different from the in-memory. Okay, so the in-memory, we just had to do everything ourselves, which we did here. But for this specific case, we're using JPA repository, which is extremely convenient. It's going to give us access to pretty much all the CRUD operations. So create, read, update, and delete, which is why we're not defining anything here ourselves. So now what we're going to do next is to provide just another implementation of that same service, but using the JPA employee repository. And that's what I'm going to show you how to do next. So let's go ahead and give the service a second implementation. So we already have the in-memory employee service implementation. We're just going to go ahead and create another one. So here I'm going to right click, create a new class, and I'm going to call this JPA employee service implementation. So IMPL, enter. And we're going to do the same thing. So that's going to implement the employee service. And of course, we have to define everything that's in the contract. So that's employee service. And we're going to implement everything. Click OK, remove this import. All right, so now I'm gonna go ahead and collapse this and go again into full screen. Since we're using the JPA employee service implementation, obviously we're gonna be using the JPA employee repository, which is this guy right here. So I'm gonna go ahead and copy this and go back to the, let's just close everything so I can see where I am. Okay, we're gonna do the same thing again. So dependency injection, private, final, let me spell final. Okay, so now we have this repository in there. Just to save time, I'm gonna go ahead and copy these two, paste them in here. Okay, so now we have, and we need to import this. Okay, so now we can pretty much do the same thing. So copy the JPA repository, and in here we're gonna call in the save. Okay, so the save is coming from JPA repository because we didn't define the save, and then we're gonna pass in the employee. And we're going to do the same thing here. Here we're going to call find all. That's going to give us the list of all the employees or a collection of them. So if you hover over this, you can see that it's returning a list. And we're going to do the find by ID. And then we're going to call find by ID, pass in the ID. This returns an optional, and we can just call get to get the actual entity. And then for update, again, this is the assignment. Okay, I'm just gonna leave this like this. And then for the delete, we can just call the repository again and call the delete and then pass in the ID. Okay, so very straightforward. We're not doing anything complicated here, and we're gonna return true here. So the delete here returns void. You can see here, it returns void, but our methods return a Boolean. So we can just call the delete and then return true ourselves here. Okay. So that's going to do the same thing. And again, if you had other business logic, then they would live inside here. Since we don't have any other business logic, and that's just a simple example, then we just call the methods and then save everything. But in real world application, you would probably have extra logic in here, maybe call to other services before you actually persist any data. And another cool thing with the JPA managing this for us is that we give it the primary key, and it's just going to make sure that all the IDs are unique. Okay, so that's something that we don't have to do ourselves. So this is good. Now, the other thing we have to do is we have to put in the database configuration. Otherwise, when we try to run the application, it's just going to go ahead and fail. So that's what I'm going to show you how to do next. So the database configuration that we need to add is pretty much going to be the same every time. So instead of typing everything out, I'm just going to go ahead and paste it, and then I'm going to walk you through it. First thing I'm going to do is to rename this to a YAML file because I like to work with YAML files better. So I'm going to change this to YML. And then in here, I'm just going to go ahead and paste everything and go full screen again. And all we're doing here is defining the configuration for the database. So we're specifying where it is. And like I mentioned, it's running on this computer on my local network. It's just some tower that I have sitting somewhere, and I just use it for coding and stuff, like experiment and stuff. And I'm running Docker on it, and I have an instance of MySQL running. So that's what I'm using here, and the username, the password, platform, and some other configuration for JPA. Okay, so I'm not really doing anything crazy here. This is very straightforward, and it's all over the internet. So you can look into each one of these properties and see what they're doing. But all we're really doing is saying, hey, this is where the database is located. Here's the username, here's the password, and show us some SQL, and then format everything, and here's the dialect, etc. So we're not really doing anything here. All right, so I'm gonna go ahead and close this. And at this point, we can go ahead and rerun the application. So that's the first test, just to make sure that nothing breaks, right? So I'm gonna go ahead and rerun the application. So stop and rerun, and let's see what happens, because I want you to see. I know it's gonna fail, by the way. And so let's scroll up a little bit here just so you guys can see what's happening. So Hibernate has created a table for us. You can see it here. It creates the employee table, and we get some more logs. And then here you can see that the application failed. Now, the reason it fails is because we have two implementations of the same service. So it doesn't know which one to choose. So you can see it here. You say we have an in-memory implementation, and then we have a JPA implementation. We need to specify which one we have to use. And there's a couple ways that you can do this. One of the ways is to define one of the bean in this case, or one of the implementation as a primary. So it's going to pick this one by default, or you can give them a name, and then you can specify which one that you want to use by passing in the name. So right here inside of this implementation, let me backtrack a little just so you guys understand. So you see here, we have one service. Okay, so if I scroll up, you see we have one service. If I can go inside of this, there's only one service. Okay, for the entire application. And I can show you that. If I go here, collapse this, you see inside of the service folder, we have only one service, which is the employee service. Okay, and then inside of the implementation folder, we have two implementations for that specific service. And that's what I showed you in the slide in the beginning. You can have one service and have different implementations for it. But the application failed because it didn't know which one to choose from the two implementation. So we have to explicitly tell it which one to choose whenever we run the application. And one way we can do this is, for example, to go inside of the first implement or the second implementation in this case, and then we can use another annotation called the qualifier. The qualifier, you can pass in a name or a value in this case. So we're going to say value and then give this one a name. So for example, we can call this we can say SQL employee service. Okay, so that's just the name that we're defining for this particular bin. And then we can specify which one to choose by using the name. So I'm going to copy this and then do the same for the in-memory. So I'm gonna go down here, paste it in there. And this time I can just call this one in-memory, for example. So this is gonna be the in-memory. I'm gonna go full screen again. So now we have two different names for the two different implementations that we have for that particular service. You can see they're both implementing the same service. So let's close everything here. Let's go back to the employee resource. So now we can use the same qualifier. So whenever we're doing the dependency injection here, to tell it which one to choose from the two. And the way that we're gonna do this is by using the same qualifier. So we're gonna go up here and say add qualifier. And then, for example, we're gonna pass in the value. The value is the default, by the way, as you can see here. So you don't have to explicitly say the value. You can just pass in the string, but I'm just showing you here. And what did we have? So we want to use the, let's go to the implementation. We want to use that one, right? So we're going to pass in that name. Let's close this, pass in the name here. Okay. So now whenever we inject this employee service, it's going to look at all of the implementation of that service and pick the one that matches this specific name. In this case, that's going to be our JPA/MySQL employee service implementation. And we're getting an error here because the required Arc constructor, it doesn't really support this. So I'm going to comment it out, and then I'm just going to do a constructor injection. Okay. So here, I'm going to pass in the value here. I can cut that out actually, and then paste it here. This is going to give us the employee service by that specific name, or the implementation of the employee service by that specific name. Okay, so we're just saying, hey, we know there are two of them. This is the one you should choose. Okay, that's it. So now if we go ahead and run again, and it's going to come up here, let me expand that a little. You can see now everything runs perfectly because it knows which one to choose from. I'm gonna go off full screen and go to the third workspace here. This should work again, but the only difference is we're not gonna see anything because we haven't saved any employees yet. So if we go to the get and send the request again, we get an empty array, okay? Because we don't have anyone inside of our database. So let's go to the posts and let's see if we can save Joseph again. So we're gonna save Joseph Robinson with this email, and let's go ahead and save. Okay, so you see this one has ID 1. So it was added in the database. And we can do Joseph 2, send, ID 2, we can do Joseph 3, send, Joseph 3, right? Now we can go back to the get, send that request again. You can see we have our data, okay? So it's working as expected. The only thing is it's using a different implementation of the same service. Now, I've opened another workspace, which is on workspace 4, and here is the database, right? So that's the database that I have. I've connected to it. And if I go to the homepage here, you can see it's the same IP address, okay? So let's go back to the connection. And this is our schema. So that's our database. I'm gonna go ahead and refresh it and expand the tables. You can see Hibernate created the employee here, and we can query that. And you can see all of the information is in here. So I didn't do this. I didn't create this table. JPA handled all of this for us. We didn't have to do it ourselves. So we get the first name, last name, and the ID, and everything seems to be working. So let's go ahead and test everything else. I'm gonna come up here using another client, in this case that's HTTP, and we're going to send the first request to get all of the employees. Works as expected. Get one employee. Well, we don't have an employee by ID 5, that's going to fail. Let's do 3, send, and we have Joseph 3. And let's go ahead and test the delete because we haven't tested that yet. So let's go over here. In this case, we have to specify the method, so that's going to be the delete method. And we want to delete the employee by ID 3. So let's go ahead and send that. And you can see here, we get true, which means it was deleted. So if I clear the screen and fetch everybody again, now we have 2 of them, okay? Because we deleted the third one. And if we go back and send that request again, now it's number 4. So the database keeps increasing the primary key, which is the ID in this case, for our employees. And if I go back to the get, send it again, I got everybody back, get the first one, and get Joseph back, okay? So everything is working and all the data is being saved in the database, and we can go ahead and check again. Well, we're not gonna see any difference because we just sent the request again, but you can see the ID is different. It was 3, now it's 4 because it keeps increasing it even after you delete the record. So you can think back of that presentation that I gave you And remember that for one service, we can have many different implementations for it. And in complex applications, sometimes you can even switch between them. So you can say, hey, try to find, a specific employee. If you can't do it, then you have to write some crazy logic and to say, hey, well, then make a request to this other service and then try to see if you can get the data that way. Like, it can get really complicated. But the point is, things are decoupled. Like, we don't have everything in one file. We have everything decoupled so that everything can be maintainable and manageable and easy to work with. And that's what I wanted to show you in this case. And here, if you want, you can even have another implementation for this service. Maybe that's going to use PostgreSQL, but you get the idea. You can have multiple different implementations of the same service. So now what do we have next? We have the API running. Everything seems to be working as expected, but it's open to the world. Anybody can come in, make a request to your API and see all your data. Now, it would be nice if we only allowed authenticated users to access the API. So we're going to jump into the security part of this, and that's what I'm going to show you how to do next.
So before we go into configuring any security in the application, I just want to give you guys a very high level overview of how Spring Security works. Now I'm going to have another course on Spring Security alone, so I'm not going to dive into all the details because Spring Security, it's not crazy complicated, but it's a little bit complicated. So you really have to take your time and understand how it works. Whenever you have a Spring Boot application and you add the Spring Boot security dependency in this application, what it's going to do is it's going to add something called a security filter chain in front of your application. So you can see in this diagram, I show all of your controllers on the right. So all of your resources and controllers, they're going to be on the right. And then the security filter chain is going to sit in front of your controllers, or actually in front of the dispatcher servlet. The dispatcher servlet is what's going to route everything to the appropriate controller, but I don't want to get into all the details. What you need to understand is Spring Security is going to add something called a Spring Security Filter chain in front of all of your endpoints. And that's going to block every incoming request unless they're authenticated. So whenever we're going to put the configuration for the Spring Security, we're going to be adding the configuration in the filter chain so that whenever the request comes in, they're going to go through the filter chain before they reach your controllers or your resources, unless you say, hey, let this specific route go through or let this specific path go through with a specific HTTP method. Otherwise, everything's going to be blocked because the filter is sitting in front of your actual application or your actual endpoints. So that's the biggest thing you got to understand. And the second thing you have to understand with Spring Security is you have to give it something called an authentication provider. You don't have to define an authentication provider because Spring is going to give one by default, but I usually override the default provider so that I can provide my own authentication provider. And the authentication provider is just what's going to do the actual authentication. So what's going to check for the user credentials. If you don't want to provide your own provider, you want to use Spring Security's own default provider, which is the DAO authentication provider, which I'm going to show you in a minute, then you can just give it something called a user detail service, which is a way of telling Spring Security how to load your users. And that can be in memory, that can be in a database, it can be in a file. It really doesn't matter where the user is coming from. As long as you can integrate it with the user detail service, then it will do the authentication for you. But in this specific example, I'm going to show you how you can set up your user detail service. So we're going to tell Spring Security how we're going to load the users and then also create our own authentication providers. And then we're going to give it some custom configuration. And that's what we're going to be doing in the next lectures. But keep this picture in mind. Understand that you're going to have a bunch of filters that your requests are going to come and go through before they actually reach your endpoints, unless you explicitly tell Spring Security to let certain requests go through. And this is all going to make sense once we start looking at the code. And this is the Spring documentation for the authentication provider. You can see there's a lot of implementations. And remember, the authentication provider is what's going to actually do the actual authentication. So what's going to check for the username or the email and the password. So that's what this is doing, among other things, but that's the main thing that it's doing. And you can see down there, it has this authenticate method that you can use. That's going to take the authentication and then do the actual checking of the user credentials. And if you scroll up here, you can see a bunch of implementation. And if you don't give your own authentication provider, then Spring is going to use this one by default, the DAO authentication provider. So one way we can do this is by just providing the user detail service. So we're going to tell Spring how to load our users, and then Spring is going to use the DAO authentication provider by default and then authenticate the user that way. And if you have a specific application, I would encourage you to dive into each one of these and see which one you would have to implement. That would be best for your application. But in our case, we're going to be using the abstract user details authentication provider, and I can open this in a new tab, and this is going to allow us to customize beginners and create our own authentication provider. And this is probably going to make more sense once we start writing all the code, but just understand that this is one of the main things that you got to understand with Spring Security and authentication. There's a bunch of other things that I'm not getting into, so Authentication Manager, the different types of authentications that you can do. I just don't want to overwhelm you, but hopefully by now you have a pretty good idea of what we're going to be trying to do. So let's go ahead and dive right into it. Now that you have an overview of how Spring Security works, even though we didn't really get into all the details because Spring Security is a little bit complicated, the first thing we have to do is to enable the dependency for Spring Security. So we're going to go inside of the POM file and find this guy right here and just uncomment that out. Okay, and we're going to reload. Okay, so everything seems to be good. We're going to close everything. Now, I'm going to go ahead and create another package and I'm just going to name it security. So we're going to say security. Press enter. And the first thing that I want to do is to create a security configuration or a web security configuration. So I'm going to right click and then do new. And we're going to call this web security configuration. Okay, so that's the security configuration for the web. So the HTTP web for our application. And I'm going to do at enable web security. And also we need the required constructors, so required aux constructor. I'm going to be defining some field here, and then I want to enable this is misspelled, enable global method security, and in here I want to define pre-post enable, and I'm going to set this to true. This is going to allow us to have security at a method level. And I'm gonna go into more details about this. This is for constructor parameter, and then this is for enabling this as a security configuration. Now, sometimes you would see add configuration also added here, but you don't need to do that because if you go in here and you go inside of this, you can see they already have the configuration. So the enable web security already has the add configuration, so you don't have to add it again. Once we add the enable web security, then the configuration is also added. And the only thing we have to do is to define a bean. So I'm gonna go ahead and say bean, and this is gonna be the public, and that's going to be the security filter chain. Okay, so that's the one that we have to define, and this is going to take the HTTP security. So we're going to say HTTP security, and we're going to call it HTTP. Okay, so now we're going to pass it in the body of the method. Remember, whenever we're gonna do any kind of authentication, we need to give it an authentication provider because that's how we're gonna tell it to authenticate our user. So to do this, I'm gonna do let's do authentication manager builder. Okay, so we're gonna call the authentication manager builder. We're gonna call it authentication manager builder, and the way we're gonna get this is calling the HTTP that get shared object. Okay, and then we're going to pass in the authentication manager builder class. So what this is going to do is just going to give us a hold of the authentication manager builder, and then we can use that builder to give it our authentication provider. You can see it come up here, authentication provider, and for now I'm going to pass in null because we haven't defined an authentication provider yet, and that's really the most important. Now, we don't really have to define an authentication provider. We can give it a user details service, and it's going to use the default DAO authentication provider, and then it's going to do the authentication that way. But in this situation, we're going to give it our own authentication provider because I want you to have a pretty good understanding of how this process works. And then we can do some other configuration, like we can deactivate cross-site research request forgery. So that's CSRF, and we're going to disable that. We don't need to use this because if we do, then it's gonna keep sending us cookies and stuff, and we don't have any browser or anything like that. So it's best to disable this because we don't need any protection from cross-site request forgery. So then we can do some more. So we have to do some more. We're gonna do for authorized requests. So we're gonna see authorized requests, and we want to enable where we're gonna allow the user to authenticate. So we're gonna say int matchers. We can do that for maybe post requests, and we're gonna allow, let's do slash maybe API slash accounts slash everything after that. Okay, so everything after that, after the slash API slash accounts, we're gonna allow with no authentication. So to do this, we're gonna say permit all. Okay, so we're gonna permit all of these.
And then we can do HTTP for authorized request again. We want to say any request. We can check that they have a specific role. So we can say has any role. So has any role. Let's define maybe user and then a role admin. Okay, so those are the two roles that we're gonna have in the application. And I'm gonna scroll up a little and go full screen. And then we can do maybe use HTTP basics. Okay, so we're gonna say HTTP basic and we can pass in with default, the customizer. So we're gonna be using HTTP basic because it's like a simpler way of handling authentication, because we don't wanna do all the token and session and JSON web token. But this is another way that you can handle authentication or web security in your application. We also have to set these as stateless. So we're gonna say session creation policy, and we're gonna say stateless, and then we're gonna return the http.build. And let's see if we can import some of these things. So we want to import the HTTP method post. All right, so that's good. And I think this throws an exception. So let's see if we can add this exception to the method. And that's all we have to do. Oh, and here we have to put a semicolon. Okay. So that's a basic, like the most basic security authentication or web security configuration that I can think of. So all this configuration is doing, we're defining an authentication provider, which we haven't defined yet. And then we're disabling cross-site request forgery. We're allowing post requests on API/accounts, and we're gonna define this in our controllers. And then we say everything else, just authenticate and make sure that they have at least a role user or role admin. So either one of these roles, they should be able to access our application. And then for the HTTP basics that we're going to be using, we're going to customize it with the default. And then we're using a statelet for the session creation policy, because we're not going to be dealing with any cookies or anything like that. So we don't need to keep track of anything. So that's all we have to do for this. And again, I'm going to have another course specifically on Spring Security. I just don't want to overwhelm you too much with Spring Security because it can be a beast in itself. But that's just the basic configuration that we need to secure the application and then provide authenticated users access to the application. That's like the most basic configuration that I could think of, and then I decided to show you. So that's all we have to do for the configuration. Now we're going to define the authentication provider. You can see it here. We don't have any authentication provider yet. I'm passing a null here just so that I don't have an error. So the next thing that we're going to do is to define our user account and then define the authentication provider. So let's go ahead and work on that next. What we can do at this point is to define users to use in the application so that we can authenticate them and then allow them access to the application. You can create in-memory users, like the same way that we did the in-memory employees. You can also create in-memory users that you hard-coded in your application, and then you can just use these mostly for testing. And I think I can get this, let's see which one. I think one of them has an example. Yeah, I think it's the authorized request. So if you go into the documentation here and you scroll down a little, so you can see a basic configuration example that they're showing you, and you can see how they're creating in-memory users, right? So I can just copy this and go down here. I just want to show you what that looks like and paste it here and import everything here. So we can define this and they will work as well. This is just users that we define in memory, which means they're hard coded in the application, right? So we have user one and then admin, and then that will work as well. Like when we try to access the application and it doesn't let us, it's going to ask us to authenticate. And if we pass in, user and then the password, then it's going to allow us because we defined this bean, right? However, we're not going to do this. The reason is because you're never gonna see this in real life, right? This is definitely used for testing. I don't think anybody's gonna use this, right? I mean, unless it's not a serious application, but this is not used, right? And I can backspace this just so I can remove the imports as well, because I don't want all of these imports. But if you hover over the authorized request and you scroll down in the documentation, you can see the example and you can just copy it from here. Okay, so you have access to it right here. All right, so now we're not gonna do that. Since we have an entire database, it would just make more sense so that we have our users in the database, and then we can use these users for authentication and everything else. So that's what we're going to be doing. Now let's close all this. We're going to come back in the configuration so that we can pass in this authentication provider, but we're going to do that later. Okay, so now let's define our users. So I'm going to call this account, press enter, and I'm going to copy some stuff from here because I'm going to use everything from here, and come down here and paste. Okay, so we're going to let JPA again manage this entity for us. And let's see if I can leverage some of this other stuff. Paste this in here. So for the account, we're going to have an ID, and instead of an integer, I'm going to just change this to a long. So I'm going to say long. Okay, so that's going to be the ID, and I'm just going to keep the ID and a username, and we need a password so that the user can authenticate. And I think we're going to need, let's do private enabled. We're going to set this to true, and private, well, that's a Boolean. And we collapse this, and we need another Boolean, and that's gonna be credentials expire. We're gonna set this to false, and private, do another Boolean, expired Boolean. We can also set this to false, and let's do another private Boolean locked. We can set this to false as well, and this is PR. Okay, and you're gonna understand why I'm defining these Boolean values, because we're gonna be using them very soon. And we need to give the user a role, so let's open up a new class here, call this a role, collapse this, and we're gonna do the same thing again. So copy all this, pass it in here, and we're letting JPA handle this, so we're gonna pass in the ID. Well, I'm gonna copy all this, pass it here, and we need the, let's do maybe private string code. We're gonna give the role a code, and private another string name. Okay, that's really important. That's going to be the name of the role. So we have the role, that's going to be the role of the user, and then we have the account. Okay, so that's going to be the account of the users that we're going to have. Now we need to have a relationship between the account and the role, right? Because we want the account to have a role. So we're going to come down here, and I'm going to go ahead and define a set. So we're going to say private set of role, and import that, and then we're going to name it roles. Okay, and let's make sure we import the set here, import Java util. So the user is going to have a set of roles. Right now we need to annotate this with let's do many to many, and whenever we load the account, we want to be able to fetch all of the role as well. So we're going to change that to eager, and then we're going to do cascade. We're going to change this to all. Okay, so whenever we delete anything or update anything, then we want to do the same thing here in the role as well. So let's go ahead and do static import for these. Now we also have to map this in a separate table. So to do this, I'm gonna do @join table, and I want to do a couple things here because we need to map the ID of these two entities, so the roles and the account, into that separate table, or the join table. So the name is going to be account table. So we're going to say, well, account role or role, and we also have to specify the column. So here we're going to say after the name we want the join column, and we're going to set this equal to @join column, and this is gonna be, the name is account ID. So account ID. So this join here is for the entity in which we're in. Since we're in account, so we're defining the account value for the join, and I have two equal signs here. So we're gonna give it a name of account, and then the reference column name is gonna be the ID. So we're gonna say ID. Okay, so this ID here is the ID that we have here. And then we're gonna do the same thing for the role. So we're gonna copy this, come down here, and instead of join column, then that's the inverse. Oh, not foreign key. Join column. So that's the inversion column, which is the role. And this is gonna be the role ID, as you can imagine, and also referencing the ID because the ID is the name that we give it in the role. So if we go in the role, it's also named ID. Okay, so this is how we're going to map this role. Now, JPA mappings can be a little bit challenging if you don't really know what you're doing, or if you don't have a good understanding of database management system and relationships. So this is coming straight from SQL. This is an implementation of SQL join, right? So we're technically saying we're going to create a join table for this relationship, which means we're going to have a table with the role ID, the user ID. And we're saying for the join column, so for the column for the ID, we're going to give it a name of account ID, and it's going to have the ID as the field, or this ID here. And then for the inverse join, which is the role, the join column is going to be named role ID, and it's going to have the ID coming from the role. That's it. So it looks intimidating, but really, if you have a basic understanding of SQL, then you know exactly what's happening here. All right, so this is good. Now, the next thing we're going to do is to define JPA repositories for the account and also the role, because we're letting JPA manage these entities for us. So let's go ahead and do that next. So let's go inside of the repository. So close everything here. I want to go into the repository. So in here, I'm going to create the account repository. So Java class, it's going to be an interface actually. And then I'm going to say account repository. And then press enter. And it's going to do the same thing here. So I'm just going to copy all this and then paste it here. Remove this comment. And instead of employee, we're going to be working with account. Okay, so we're going to change this to account, change the type of the primary key to a long, because that's what we define. And let's make sure we import this. All right, and then remove this unused import. And we need one method in here that's going to allow us to retrieve an account. So we're going to say account, and we're going to do find by username, and we're going to do a string username. Okay, pretty straightforward. We're just going to use this method so that we can find an account by passing in the username. And now that I'm thinking about it, we need to make the username unique, okay? Because whenever we're going to call this function, JPA in the background is actually going to run a query and then to find by that username, or where this username equal whatever we're going to pass here. So if it doesn't find one, it finds multiple, then it's going to throw an exception. So we can come back here, and in the username, we can define a column. So we're going to say column, and then we're going to say unique. Set this to true, and that's going to handle that for us. So whenever someone has an existing username, we're going to try to pass another one. And if we use the same username, then it's going to throw an exception. Okay, so that's taken care of. All right, so this is good. Now we're going to do something similar for the roles, because we want to be able to save a role. So I can just copy this really, and then here I'm going to create a new interface. That's going to be the role repository. Press enter. And let's go to the account, copy all this, and then paste it. And here we're going to be working with roles. So that's going to be role. Make sure this is imported. And remember, in the role, we have name. So we can do find by name. Okay. And then here we can pass in the name. All right. So this is our role repository. And it returns a role instead of an account. All right, so this is good. Now we have the repositories for the roles and also the repository for the account, which means we can create a service and then create implementations for the service. In this case, we're only going to have one implementation. I was just showing you how you can have different implementation with this in memory, and I did this for the employee, but we're not going to do that for the users, because at this point you should be able to understand what I was trying to teach you. So we're going to define a service, and then we're going to have an implementation for the service for the account, so that we can start working with fetching account from the database and then pass this information to the authentication provider so that we can complete the security setup. So that's what we're going to be doing next. So what we're going to do now is to define the service for the account. But before I do, just so you can have this for yourself, I'm going to copy the repository here and then pass it in here. Like I said, it's not required, but just so you know what's happening here, because when I was learning, that helped me a lot, because I can see the annotation and I'm like, okay, that's the repository. So I added the repository annotation to the account repository and also the role repository. But like I said, it's not required at all. So let's close everything here. And what I want to do, I'm going to go full screen again, is to go inside of the service folder, create a new class that's actually going to be an interface, and then I'm going to call it the account service Okay, so in here, we're gonna define the contract that we wanna have for the account. And the first one that I wanna have is gonna return an account is to create account, okay? Because we want to give users access to create an account, and that's gonna take the account, which is gonna be the account, okay? So that's the first one. The second one, also gonna return an account, is gonna be find by username. So they're gonna give us a username, and then we're gonna see if we can find the account. So we're gonna say username, okay, fine. And then we can maybe return a list of all of the accounts. So we're gonna say account, and we're gonna say get accounts. Doesn't take any parameters, and let's make sure we can import the account here, import and import the list, Java util. Okay. All right, so this is the account interface or the account service, and these are the specifications that we have. So now what we can do is to define an implementation since we already have the account repositories. So let's go up here and let's open this up and create a new class. That's gonna be the account IMPL, and this is gonna implement the account service. Of course, we have to define all these methods now. Click OK. All right, and then here we're just gonna bring in the repository. So private final account repository, and we're gonna name it account repository, and we're gonna define this at service and also required args constructor. Okay, so that our dependency injection can be done. And you can see at this point, it's really just a rinse and repeat, right? As long as you understand how this thing works, then you're just gonna do rinsing and repeating. So I'm gonna bring in the role repository. So I'm gonna do private final role repository, because we're gonna need to fetch the role so that we can assign it to the user. And lastly, I'm gonna need something called a password encoder. So we're gonna say password encoder. I'm gonna call it encoder. Okay, we're gonna need to define this bean because it's not defined anywhere. All right, so when we're gonna create a new account, what we want to do is we want to encode the password, because when you're using Spring Security, you can't store the raw password in a database. You have to encrypt it. And one of the best encryption method that they have is using the password encoder, which you can use with bcrypt encoder. So what we're gonna do, the first thing is gonna be to set the password. So set password, which we're gonna get from the request, but we're just gonna encode it so that we can save the encoded password. So we're gonna say encode and then encode the password that we get from the user. So we're gonna say get password. So on the account, which already has the password, but it's the raw password, we're gonna set the password again and then encode the raw password. So it's gonna override the raw password here. So now we can see if we can find some role, and we're gonna say role repository, find by name, and then we're gonna pass in maybe like role underscore user. Okay, so every time someone create an account with the application, we're gonna give them a role of user, and we can define a quick set here of role and say roles, and then we're gonna say that's a new hash set just so we can pass something to the user, and then we're gonna say roles that add pass in that role. Let's import this. Okay, and then we can set this role on the account. So we're gonna say account.set roles, and then we're gonna pass in the roles, okay, which is the set. And then at this point, we have the roles on the account. Then we can go ahead and save the account. So here we're gonna call the account repository .save. And then we're gonna give it the account. Okay, so the account is gonna be saved with the roles and everything. So that's what we're gonna be doing most of the work. After that, everything is gonna be pretty straightforward because again, we don't have a complex application, so we don't have any complex logic. Here we're gonna pass in the username, so that's pretty straightforward. And then in here, we're gonna pass this again and call find all. Okay, so that's just gonna return all of the accounts that we have saved in the database. So you can see how easy it is to work with JPA because it makes everything so much easier and everything is hidden from you. You only focus on your business logic. And I'm gonna rename this to account, supposed to be account service implementation. Okay, so make sure you fix that. All right, so we have the account service implementation. What we're gonna do next is to define a configuration and then define the password encoder for the account service implementation. So let's go ahead and do that next. let's go ahead and define the configuration for the encoder. So I'm going to go back here, and inside of the security, I'm going to create a new class, and I'm going to call it security configuration. So that one is named web security configuration because it's regarding the web, and this one is just a generic security configuration. Then I'm going to press enter, and at the top here I'm going to annotate this with configuration, and then we just need to define this password encoder. So I'm going to define it as a bean. So I'm going to say bean, and then we need the public, and that's the password encoder. We're going to give it the name of password encoder, and then all we have to do is to return a new bcrypt password encoder. That's it. And if we had other beans that we needed to define for the security configuration, then we can use the security configuration class to do that. But for now, we only have this one bean, so we're just going to define it in here. Okay, so let's go ahead and close this. Now, the other thing that we have to do before we can create the authentication provider is to define how we're going to tell Spring to load our users. And we know that our users are in the database, so that means that we're going to use the account repository and then tell Spring how to load the users. So that's what we're going to be doing next. And just to explain this again one more time, we know how we can load our users, but Spring Security doesn't know. So to tell Spring Security, you just have to implement the user details, and that's how you're going to tell it how to load the users. And we're just going to use the same method that you see here to load the user, and then give it to the user detail service, and then we can use that detail service in our authentication provider. So let's go ahead and do that. So the way that we're going to do this is by just going inside of the implementation. So let's go down here. So we have the service folder, and then we have the implementation. So let's go in there, define another class, and then I'm going to name it user details service IMPL, okay, because that's what it is. And then here we're going to implement user details service. Okay, that's coming from Spring's framework. And then we're going to define this method here, which is load user by username. Okay, so once you implement this, you can give it to your authentication provider, and then it will know how to load all the users or wherever you're loading your users. So again, the first thing, we're going to pass in the repository. So we're going to say private final account repository. Pass in the account repository, and let's see if I can copy some stuff here. I need this guy right here. Okay, I'm gonna collapse this. And also this is a service, so we can define it. We can define it as a service. So everything we've been doing with the other classes, because we're still just implementing an interface here. So if we go in there, you can see just an interface with just one method. It's the same thing that we define. All right, so now we can just use this repository, or actually we don't even need the repository. We can pass in the account service, okay? Because it's gonna do the same thing. The service is gonna call the repository, but in this case, it makes sense to call the service, because if we have a different implementation for that specific service, then we don't have to come in here and change it. We're just gonna use the contract itself, which is the service. Okay, and I'm gonna clean the import up here. All right. Okay, now all we have to do is to tell Spring how to load this user, and we know how because we have our service here. So the first thing, we're gonna try to find an account. So we're gonna say account, that's gonna be account, and then we're gonna say account service find by username, and then we're gonna pass in the username. Okay, so we're gonna try to find an account, and if the account is null, so we're gonna say if account equals null, then we're gonna say, well, we couldn't find the user, then throw an exception. So we're gonna say throw new user not found exception, and then we're gonna say user by that username not found. Okay, this can be whatever message that you want. We can do another check, so we can say if, and we can say account that get well, let's make sure we import this so that we can get autocomplete. Okay, so we can say account that get roles, and if this is null, or if the account that get roles that is empty. So if it's empty, we're gonna say, well, we can't manage any user with no roles. Okay, so we're gonna say throw new. That could be a runtime exception. runtime exception, and then we're gonna say user has no roles, okay? Because we can't work with a user with no roles. Otherwise, so we know that we got a user, we can create a collection of granted authority. We're gonna just name these authorities, and then we're gonna set it to account that get, and we can just stream, and we're gonna map. So we're gonna try to change every single one of them. So we're gonna say for every role, we're gonna say return a new, let's do a new simple granted authority, and we want to get the role name, okay? Because the simple granted authority, it takes a string, and we can go in there real quick so you can see the role is a string, and it's just gonna assign it to this role here, okay? So that's what we're doing here. And then finally, we can collect this to a list, and this is going off the screen, and see if I can clean this up a little. All right, so now we have all the authorities, and then here, well, we don't need this space, we already have a return here. We're gonna return a new user, which is the user coming from Spring, and then we're gonna say account that get username, account that get enabled, so is enabled, and then account that is expired. For the is expired, we're gonna have to reverse this because we set it to false. So let's reverse this, and then account that is credential, and also we need to reverse this because we set it to false. And then again, account is locked, and then the authorities. Okay, so let's go ahead and return this guy right here. Import. This is supposed to come from Spring Security User Details. And one thing we're missing is the password. So we're gonna say account get password. Okay, that looks good. And I'm gonna move some of this down so you guys can see everything. Okay, all right. So now that we have this, we can give it to Spring Security and our authentication provider, and then tell it how to load our user. And it's only going to use this load user by username. And since we know where the users are stored, then we tell it where to look, which is inside of our account, which is the account service implementation, as you can see here. So that's what we're doing. So the next thing we have to do before we can hook up on the last piece of the security configuration, which is the authentication provider, is to create the authentication provider. And that's what we're going to be doing next. So let's go inside of the security here, and I'm going to create a new class, and I'm going to call it the account authentication provider. Press enter, and here let me collapse this and go full screen. We want to extend a particular class called abstract user details authentication provider. Okay, so that's the one we're looking for, and I'm going to tell you why we're extending this class and overriding these methods. And let me just do the dependency injection first. So user detail service, Okay, so you see that I'm using the user details from Spring, right? So this is the user detail. However, because we have an implementation of it in our application, then instead of using any default implementation or anything like that, then it's going to use the implementation that we have in our service because we have an implementation for it, or we have a bean for it. So I'm going to copy the required constructor here, and also I'm going to annotate this with the add component so that it can be picked up by Spring as a bean. Okay, so now all we have to do is to authenticate the user here. So you can see additional authentication checks being done here, and then how to retrieve the user. And one last thing we need is the password encoder. So we're going to say password encoder. I'm going to call it encoder. Okay, so we have the encoder because we're gonna need it to compare the password. All right, let me collapse some of these. Okay, so what we're gonna do in this method, which is the one that's doing the additional check, we're gonna check the credentials and the password. So I'm gonna come up here, and then I'm gonna say if the let's move over here. I'm gonna rename this to token. Okay, this is actually the authentication. I'm gonna rename it to authentication. Okay, that makes more sense. So in the authentication that get credentials, if these credentials are null, right, or if the user details get password, if this is null, because we're gonna need to check these, then we have a bad request. So we're gonna say throw new bad credential exception, and then here we can say credentials may not be null, okay, because that's what we just checked for. Okay, and then we can check the password. So here we can say if we're gonna call the password encoder, so we're gonna say password, well, we actually call it encoder. If the encoder that matches, we're gonna compare the two strings. So we're gonna say authentication that get credentials, and we're gonna pass in the user details that get password. Okay, so we're gonna compare the authentication and the user detail password to make sure they're the same. If they are not the same, then we're gonna do the same thing again, which I'm not gonna type. Okay, and in here we're gonna say something like invalid credentials, and this has to be turned into a string because it's an object. If you can see here, it's an object, but since it's an object, then we can cast it to a string because we know it's going to be a string. And then now we can just reverse this if statement because we're checking to see if they match. So only if they don't match, then we're going to throw this exception. So that's all we have to do for the additional authentication checks. And then for the retrieve user, which is how we're going to tell it how we're going to load the user, we're going to just call the user details and then call the load user by username, and then we pass in the username. You can see the username is being defined right here, and that's all we have to do. So this is gonna make it really convenient for us because when we implement the user details, which is here, it's returning the user details. So the object type that this is returning, instead of us trying to like do getters and setters and mapping things, we just implement the user details and then we call it again here. But because we have an implementation of it, it's gonna use our implementation instead of anything else. Okay, so I hope that makes sense. And at this point we have the authentication provider, so I'm gonna copy it and close all this and then come up here, and then I'm gonna inject it here. So I'm gonna say private final, oops, okay, and then we're gonna pass it here. That's it. So now we not only tell Spring Security how to load our user, but we give it the authentication provider. So now we have everything we need in place, which means if we run the application right now and we don't have any users, then we won't be able to access anything because we can't authenticate. We don't have any users in our database. So the next thing to do is to set up our database, put in some roles in there, and then save some users, and then test the application again. So that's what we're gonna be doing next. So what I'm going to do is to just close these, and I'm just going to create a functionality to allow to create a new account. So I'm going to collapse all of these. You can see we have a number of folders and files here. And then in here, I'm going to create a new Java class, and I'm going to call it account resource. Okay, we're going to keep this minimal. I'm going to leverage some of these, copy all this, paste it in here. Okay, and this is gonna go to accounts, import this right here. Okay, we need to inject the account service, so we're gonna say private account service, and that's gonna be the account service. Okay, and I'm gonna leverage maybe this post request here just so I can save some time. So here we're gonna return an account coming from our domain. And let's call this create account. Okay, go full screen, and we're gonna pass in the account. And I'm gonna get rid of this. Oh, by the way, we need to fix this. So we don't need this line anymore because we're not using the in-memory. Okay, so just remember to remove that. All right, so here we're not gonna do this. We're going to create an account, which is going to be the new account, and set it equal to the account service, that create account, and then we're gonna give it the account. Okay, so whatever account that they pass in the request body, we're gonna give it to the service. Service is gonna call the service implementation. Service implementation is gonna call the repository. Repository is gonna call Spring Data JPA, and Spring Data is just gonna go ahead and save it for us. Now we have this new account. We can pass it in the body like so, and then we can get the ID as well on the account. And I think we can go ahead and change this so that we can use it in both places. Let's go here, and instead of private here, I'm gonna make this protected. Okay, so that it can be used in the same package. And then just to make it static, I think that should fix the problem. Import it. There we have it. And if you remember, this takes an integer. So from the ID, we can do that int value. Okay, so we're gonna get the integer value from the long. Okay, so we're leveraging the get location because this is also a create. So we're leveraging this. And the next one, I'm gonna type it out. It's gonna be a get mapping. It's gonna be public. It's also gonna return a response entity of a list of accounts, and we're gonna call it get accounts. No parameters. And then in here, we're gonna say return response entity of okay. So we're gonna call the account service that get counts. Okay, and we need to import this. And I think I imported the wrong list. We don't need the employee. Yep, that's the wrong list. We want the Java util list. That one. Okay. All right, so now we have a way to create an account and then get all the accounts, and we need to make this final. All right, so that it can be picked up by this annotation. Okay, so that looks good. So if we run the application now, everything should work. Okay, so we've edited a lot of code. I might have missed something. Maybe you caught it, I don't know. But I'm gonna go ahead and run the application and then try to test it and see if it works. All right, I'm gonna go ahead and run the application. So run. All right, let's see what happens. Okay, it's coming up. Yeah, it's creating the account and everything. Okay, looks like we're good, supposedly. All right, I'm gonna exit full screen, and then I'm gonna go to my setting workspace and clear this out. If we try to go to employees, that should give us a 401, which is unauthorized. So let's run this, and you can see right here, we get a 401, okay, unauthorized. And we can see that it's using the basic authentication scheme here. If you want to see that clearly, we can go up here in Postman and then run the GET request again. You can see 401 unauthorized because the application is secure. So I'm going to duplicate this tab, and we want to go to accounts because we don't have any login credentials or anything like that. There's no users. And I think let's go back to the app and minimize this a little. Close all this, also close this. Gonna go into the model. Just want to see what I need to pass. So we need a username and a password. Everything else has a default value, and we know we're not passing the roles. Well, this is gonna fail because it's gonna look for specific roles that we don't have. So let's go ahead and fix that first. You can see, well, I don't know if you guys remember, but inside of the implementation here, account and service implementation, you can see we're going to look for role user, and we don't have that role in the database, right? You can see everything was created. If I open this up and scroll up, so it creates the account table, then it creates the relationship, and then it creates the role, but we don't have any insert in here. So there's no role user inside of the database, and we can check this out actually. So if we go here and we refresh, you see we have the account role, which is the relationship between the account and the role. You can see the role here, but if we look inside here, there's nothing. There's no roles. So there are many ways that we can fix this situation. We can put the roles in here manually, and then whenever we're gonna call the find by name, and then it should be in there. But I don't want to do it that way. I'm gonna show you a different way you can do this. So I'm gonna minimize this and go back here, and I'm gonna create another package here. I need a package, so right click again, package. I'm gonna call it init. Okay, you can come up with a better name for this, but I'm just gonna call it init. And then inside of there, I'm gonna create another class and I'm gonna call it application start runner. Okay, and I'm gonna implement the command line runner, I think it's called. Okay, that's the one. And here I can just implement that one method, which is the run method. Okay, so what I can do if I want to save some roles, I can even do it for users if you want. We can do final, and we want the role repository, so we're gonna say role repository. So role repository, and because we don't have a service for the role, okay, so the role repository, and then here let's see if we can grab this constructor, and also we need to annotate this at component so that it can be picked up. All right, and inside of the run we can define some roles, so we're gonna say role user, and then set this equal to a new role. And let's give it a 1, or that's a long, so we have to give it an L, and then we have to give it a code. I'm gonna do 1 to 3, and then here we're gonna say role underscore user. Okay, and let's import everything here. Import, then paste this down. This is gonna be 2, 4, 5, 6, and admin, and then we're gonna change this as well. Admin. Okay, so we have two roles. We have role user, role admin, and then we can call the role repository save all, and then we can pass in this as a list, role user, role admin. Okay, so let's import this list, import static. Yep, that's the one that I need. Okay, that's good. So what's going to happen is after the application start, it's going to run this command line runner, which is going to run this method. So it's going to go ahead and save these two roles inside of our database so that when we look for this role user, it should be in there. And we could do the same for users. Like if we didn't want to create the users ourselves using Postman or something, then we could define, you know, maybe the account service or something, and then create 2 new users or something, and then save them in the database so that we can use them for testing. But we're going to do that in Postman. So now all we have to do is to run the application again, and then we're going to send a request to create a new account and then test the functionalities. All right, I'm gonna go ahead and rerun. So stop and rerun, and let's see what happens. Application is coming up. Let's take a look. Okay. All right, it looks like it did. You can see here, insert into role, and then you put in the information. So now we can double check by going in here and then rerun this query. You can see we have the 2 roles in here. Now let's go back and let's go to Postman, and then here we're gonna pass in the username. Change this to junior, and the password 1, 2, 3, and I don't think we need anything else. Okay, so we're gonna create a new account. We're gonna send a post request to /APIs/account, and we're gonna pass in the username and the password. And let me just double check that's what I'm passing in here. So username, password. Okay, so that's all I need. All right, so let's go ahead and send this. Okay, you can see the user has been created, and we have an ID 7, everything looks good, and then we have the role, which is role user with the code 1 to 3, ID 5. So everything seems to be working, but there is one problem, which is this guy right here. We never want to return this password at all, because that is really sensitive information, okay? So one way we can fix this is to, well, hold on a second. Let's duplicate this one more time, and let's send a GET request this time so that we can get all of the account. We're gonna pass in nobody and send the request. I got a full one unauthorized. Okay, so that's good, because if you go back, go to the, close all these, resource, account resource. So we have a, let's scroll over here. Okay, so we have a post mapping for API/accounts, which is allowed, but the get mapping for /accounts is not allowed. And if you remember, inside of our web security configuration, we said for /API/account/ anything after that, we're allowing only post requests, which is why it worked for that one, but it didn't work for that one. All right, so we won't be able to test what I want to test yet, but that's okay. So let's see if we can log in now with these credentials. So let's go back here. We're gonna get rid of this password in a second, but let's see if we can fetch all of the accounts, for example. So in here, when we fetch the accounts, it says 401 unauthorized because we're not authenticated. So what we can do is to go to authorization and we're gonna select basic authentication. Okay, so that's the one. And then here, well, I'm gonna pass in junior and then 1, 2, 3 show. So is that what we put in? Yeah, 1, 2, 3. Okay, so now we're gonna access all the accounts and send this request. You can see it works. I'm gonna duplicate this, and when I duplicate it, it's gonna keep all the credentials so that I don't have to type them again. And this time we wanna go to employees. Okay, you spell employees, right? So now if I send this, you can see I can access all of the employees again. Okay, so I got a 200, okay. But if I go back and I said no auth, so I'm passing in nothing here, I said it again, unauthorized, okay, because I'm not logged in. Go back, basic authentication, send, I can see the data, okay? So that is working as expected, no problems here. Now, to get rid of this password, we can do something very simple. Let's go back in the application and let's go inside of the accounts, and in here at the top of the password, I'm gonna pass in an annotation, which is the JSON property. And here I'm gonna say access is going to be write only, okay? And I'm gonna do a cleanup here. All right, and then I'm gonna rerun. So we can write, but we can't read this field. That's all this is. So let's go ahead and rerun. Okay, we seem to be in good shape again. Let's go back here, well, not here, send. Let's see, the password is no longer there. So that's how we get rid of the password. And just for a sanity check, I'm gonna make sure that I can access everything else. So here, if I send this again, unauthorized, basic auth, 1 to 3, okay, send, I get it. If I try to access one employee, send, unauthorized, authorization, basic auth, same information, send, I can access. Okay, and then the post request, go back here, and authorization, basic auth, it saves the information, send, the user is created ID 10, send it again, ID 11. Okay, and we can go back to the database, go to employees, send, we can see the data is in there. Okay, so we've successfully created authentication in our REST API, and we can see that everything is working as expected. Now, what we're going to be doing is some refactoring and some cleanup. So let's go ahead and do that next. So let's go ahead and go back to the application, and I'm gonna close all these tabs here. And what I want to do is to just go in every single package and see what I can make better. So first thing, I'm gonna rename this all directories, and I'm just gonna rename these to something like API. Okay, I think that's too long for a name. All right. So everything is refactored. So inside of the init, and I already explained why we're doing this, because we want to run some code after the application started. But there are many different ways you can do this. You can use the event. I think there's an event that gets fired, like an application event that gets fired whenever the application is started. So you can use that event as well. Just listen to it, and then when it's fired, then you can run your code. There might be a couple other ways to do this, like with some annotation. I can't remember off the top of my head, but I think there's like 2 annotations that you can use to execute some code. So for this specific example, there are many other ways to do it. It's going to depend on your application and what you're trying to do, but this is a pretty good way to do it as well. So that's that. And then for the model, let's look at the account. One thing that I'm noticing, we allowing requests to come in without a username and a password. So we brought in the, let's go to the pump file, the validation. Now this is a very powerful dependency, and we really didn't use it in this application, so we can come up here and do at not null, and we can do the same for the password. Okay, so that's gonna stop any request coming in without the username and the password in the account. Inside of the resource, the account here, we're passing in the account as the request body, but you would have something like a DTO instead of the actual business logic model or entity here. You would have some kind of a mapping mechanism where you're going to map this account to like a data DTO, and that's what you would pass in here. So that's another thing to keep in mind, that you wouldn't really pass your actual entity inside of the resource. And usually these entities, they have a lot of fields, and you don't want to have to pass this in here. It's gonna just break things. You might have lists and collections and sets and things, and it's just not the best idea. And also, we don't really have a lot going on. This example is mostly focusing on the API, how to build one and then secure it, because we don't have anything here. For example, for this user, we have a username and a password. We don't have anything else. All these are being passed in for Spring Security because we need to tell Spring Security if the account is enabled, expired, or unlocked. And we could pass in hard-coded true false values as well, but I just do this. But we're not doing anything with these really. We're just setting hard-coded values. And the reason for this is because I'm gonna have an entire separate course on Spring Security alone, because Spring Security is one of these things about Spring that you really have to take your time to understand. And once you understand it, you're gonna realize that it's really easy to work with. And also mappings, relationships like this can be a little bit intimidating. I remember when I first started, it was a little bit challenging for me to understand what was going on. I really had to go back and then reread everything with a lot of attention just to make sure that I understand what things were doing. And also I took a class about SQL when I was in school. So then I was like, oh, okay, everything's connecting now because I can see the joins and everything else and the mapping and the one-to-one. So another thing that can help you really understand this mapping is SQL. So if you understand how entity relationship mapping is done in SQL, then it's going to be really easy for you to understand what this is doing. And that's that for this. And for the, well, I'm here for the employee. Well, that's just an example. That can be anything. Really, there's no logic in here either. That was just a simple example. So not much to say here. And in the role usually are represented by enum, at least the role names, as you can see here. Instead of a string, you can see in the init, I'm passing in a hard-coded string. You usually don't want to do this. You probably would use an enum and then use the enumerated annotation to either save it in a database as a number or as a string. But you wouldn't pass like a hard-coded values like this because it's really prone to error. Like I miss an R or something here, or I put a space here or something, then it's gonna fail the entire application, and you don't want that. So for the roles, usually for at least the name here, you would have some kind of enum that you can use so that you can make it less error prone. And also another thing, we can make this role extend the authority, which is gonna return the name, and that's just another way you can implement this. There's like so many different ways you can do this, and it's gonna make it easier for you when you're, for example, if we go inside of the user detail service, you can see how I'm getting the authorities here. I'm mapping over everything, and then I'm getting the name for each role. And if you extend the granted authority here, it's going to make it a little bit easier when you have to do all of these mappings, as you can see here. But that's not a big deal. And also another thing about roles, you can see I have the role names, which is going to be the role user, role admin, manager, etc. But I don't have any permissions or authorities, right? And that's something that you got to understand. For example, roles, so if I say role, that's like high level. Okay, that's high level. And then we have permissions or authorities. That's more fine grain, or I'm just gonna say more specific. Okay, so sometimes you might not care what role someone is, but you just want to make sure that they have a specific permission or a specific authority. So then you would use something more specific like an authority. But in this case, I'm just using role, even though when we're doing the mapping, you can see that Spring is naming it an authority or a list of authorities. So roles and authorities, role is more high level, authorities is more specific. So that's that. And that's it for the models and the init. Repository, pretty simple. I usually don't use Spring Data JPA when I'm working with complex projects. I only use it in parts and mostly use JDBC with SQL because I know SQL to some degree, and I like to use SQL because it's very flexible and I can do many different things with many different tables. So my personal preference is not using JPA if the application is going to be a little bit complex. But for an application like this, it makes total sense to use JPA because we're not doing anything, you know, mapping and using many different tables and things like that. So that's pretty good. We don't have to do much here. And JPA is also very good to understand because you can build application really fast. Okay, so that's another thing. And also very flexible, so you can extend it if you want. You can even override the methods inside of the JPA repository. Like for the save that we're using, the save all and find all, you can override them and give your own implementation. But this is going to require you to really understand how the framework works and understand how to write your SQL in a very performant way. So you don't want to go ahead and override all these methods that, you know, some expert has written unless you really know what you're doing. And that's true for all the repositories here. And this in-memory one was just an example, and hopefully it served its purpose because I really want you to understand that you can have different implementations for these things. And so that's for the repository resource. It's pretty straightforward. That's just a resource. That's what's exposed over HTTP. So there's not much to say here. Another thing is we're not handling exception, by the way. That's not something that's covered in this course. That's just beyond the scope of this course. But you can see that in this entire application, I'm not handling any exception. And that's a big no-no because you don't want to spit out long exceptions like when something goes bad in the application and then it's going to throw an exception all the way to the front end. So you want to make sure that you handle exception, and Spring makes it really easy to do that. I'm just not covering that in this course, but it's something you really have to think about and make sure you do because you don't want to expose your application. And for security, well, Spring security in itself is a broad topic, and I would much rather have a separate course focusing only on Spring security because there are many different classes and filters and things that you can do and ways that you can implement this and all the defaults as well, because we could just have a simple configuration with no authentication provider and it will still work. And that's because there's a bunch of defaults that Spring security implements that will take effect even if you don't pass in a lot of configuration or no configuration at all. As long as you have the dependency inside of your POM file, then it's gonna kick in. So I'm just not gonna say much about this because I'm gonna reserve this for a course on Spring security itself. And configuration, that's just a configuration. There's not much to say here. Authentication provider, I went over that a little bit in the slide before we jumped into the security, and I think that's it. There's more to say, but this is going to be a course in itself. Services, I explained that pretty well to you guys so you understand. Services are specifications, they're a contract. You can see there's no implementation. We're just defining what needs to be done, and then we have implementation for these. So, and then in here we have the actual implementations. Okay, and you know that you can have multiple implementations for one specific service. And that's the main application file. There's nothing to say here. And what else? And then we have the resources. So we have the static folder. If you were serving static files, you would put them in here. But nowadays, I don't see a lot of people building this kind of Spring Boot application. People just build REST APIs or microservices, and then they use a client application like a React application or a Vue application or maybe an Angular application, and then they communicate with the application that way. So that you don't see people building this kind of application with like JSPs. I mean, there's a lot of legacy applications like these. So if you're looking for a job, that might be something you might want to learn. Moving forward, you probably should focus on building microservices and working in the cloud. But this folder is here. If you want to serve static files, then you can do that. And inside of the template, you can put different kinds of templates. I usually use them for email templates. So whenever I'm sending an HTML email, not just email with text, but email with pictures and media, then that's where you would put this in there. And then this is your main application file. So that's the main application properties file. This file is being read by Spring Boot when your application loads up, and you can put a ton of configuration in this file. Also, you can have multiple ones of this file. So for example, I could copy this and paste it in here, and if I do dash if I configured profiles, for example, and I do maybe dev and then save it, then Spring is also, well, it's not supposed to be here, it's supposed to be in the resource. So Spring is going to read that as well. It's going to read it if you have the dev profile active, then it's going to read the dev profile. And you can set the profile inside of here, or you can configure it in the pump file. I prefer to configure it in the pump file because I have more options when I do that. But in this case, we're not covering profiles. So I'm just going to go ahead and delete this. All right, and I think that's it for now. And one last thing is this folder right here. This is really important. This is not something you see a lot of on the internet or in terms of resources if you do some research. Not writing tests for your code is never acceptable. Like, it's a big no-no. You can't work for a company or write your own application and not test it. Even though you see that in many tutorials, maybe like 95, 98% or 99% of them, there's usually no tests. But in companies, or if you're working on a structured way, like you have maybe a tech lead or a team in a professional setting, you always have to write tests for every line of code that you put in the application. And sometimes it can take you even twice the time that it took you to write the actual code when you're writing the test. So the test can take a lot of time. You can see here, I don't have any tests for this application at all, and that's not good. So if you really trying to be a software engineer, I would say if you feel okay, like you really getting the gist of it, focus on test 2, because you can't really work for a company or work on a serious project and not have unit tests and integration tests to the very least. So really important, this folder, even though nobody's talking about it. I haven't made a course on testing. I have projects and I have tests written, but I haven't made a course on testing because I have other things that I'm already working on that I already have on my schedule. But testing is really important. Like, you can't build an application in any acceptable / professional way, even if it's your own application, and not have tests for it. So really important just to keep that in mind, because you're going to have to write tests every time that you write any code in the application. You have to test it, at least with unit tests and integration tests. Maybe not end-to-end tests, depends on the application, but definitely unit tests and some integration tests, definitely. So I hope this was useful to you, and really we rushed a lot of this because we could take more time to go into more detail about all these things. It's just so much of information, and as an instructor, it's sometimes a little bit challenging when you have to choose between what's really important to teach and what's not that important to teach, and what you should mention and all these other things. So it's really hard to find the right balance in terms of what you should teach, because you have accumulated a lot of knowledge over the years with experience, and teaching it is also a different thing. So just because you know something doesn't mean you know how to teach it well or teach it at all. So if you have any feedback or any suggestions or anything like that, so feel free to reach out to me and let me know, and I can take that into consideration for the future. So at this point, the application is built. What we have to do now is to Dockerize the application and then see if we can deploy it on a server. So that's what we're going to be working on next. I'm gonna go ahead and close everything that I don't need. So I don't need this anymore, and I don't think I need Postman anymore. And I'm gonna need the terminal, so let's clear this. And let's go to my first workspace. So the application is done, it's completed. You can take the code. I would say at this point you should definitely take a break and look at the application. Maybe spend a few days just making sure you understand what's happening in the application. Make sure you get it. If you have any questions, of course, reach out to me and let me know. I should be able to help you. And if you want, you can even take like a couple of days or a few days or even a week. Make sure you understand everything at this point before you come back to look at the deployment with Docker, because that's just a different architecture in itself. Because you don't want to overwhelm yourself and take everything all at once, because we already cover security, and the security part of this can be a little bit confusing. I felt like if I just did the API part, so just the employees and stuff, it wouldn't be substantial enough for a course. So I decided to show you how you can secure it using Spring Security and also deploy it. But at this point, you should definitely take a break and then make sure you understand everything. And once you feel confident, then you can come back to continue with the deployment. So one thing I want to bring to your attention is how the application is packaged. There should be a jar in there, but I don't see it. So let's go back here again and package. Okay, so that's gonna package the application into the jar. So let's run it and let's wait. Okay, it's gonna run tests again. I should have said skip tests, but we shouldn't have any tests, so nothing should fail, hopefully. And okay, so let's see here. Okay, you ran that one test and it passed, and we have build success. If we go back here now, you can see we have a jar file, which is this file right here. Okay, the snapshot one, blah, 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 that one. This jar file is the package application. Inside of there is everything that we just wrote. So if I go back here, clear this, go inside of the target folder, and then list everything, we're gonna see the jar file. What I want to show you is if you have Java installed, you can run java-jar and then you pass in the jar file. That should run the application the same way. So if I run this, I have Java installed, by the way, you're going to see it's coming up just like we just ran it in the IDE. Okay, so it's going to do the same thing. So what that means is that whenever we package the application, all we really care about is the jar. And I can open another terminal here on the side. When you open a terminal on my system, you have to pass in your password. And I can do HTTP and then go to 8080, maybe go to API employees. This is gonna fail, so I have to pass in my authentication. I do this by doing -a junior and then 1 2 3. That should work, hopefully. Okay, so you see it works, okay, because I pass in my authentication here. So you can see the application is working by just running the jar file. And I'm gonna exit this because I don't want to have it here. And then I'm gonna stop the application. So the point that I'm trying to make here is all we need is this jar, okay? Whenever we run the application in Docker, we're gonna package the application with the Maven command, and then we're gonna get this jar. And that's the jar that we need to run with the same command that I just showed you, which is java-jar. So now you understand this. I'm gonna go back. And then I'm going to open Vim, okay? Because I use Vim a lot. We can do it in the IDE, but I just want to show you how I'm working in the terminal itself. So I'm going to open Vim and I'm going to create a file called Docker file. This is the file that you use to create an image for any container that you want to run, okay? So I'm going to open this, and the first thing that I want to do is to get Maven. So I'm going to say from Maven, and I'm going to pass in the version 3.8.6. That's the latest version. Oops, 8.6. Okay, and that's the version of Maven that I want to start with as my base image. And I'm going to define this as a build, and I'm going to talk about this in a second. The second thing that I want to do is to define a work dir, which is the working directory, and I'm going to set it to app. Okay, so that's going to define a folder called app inside of the container. And then I'm going to copy the pom file. So I'm going to say pom.xml. XML, I'm going to copy it over to app. Okay, and then I'm going to run the MVN, because now I have Maven on line 3. I have Maven, well, line 1. Let me deactivate relative line number. Okay, so on line 1, I have Maven. Because I have Maven, then I can run MVN command. And then I'm going to do dependency resolve. What this is going to do is not going to run the application. It's just going to look at the POM file and then download all of the Maven dependency. And then after that, I'm going to copy the rest of the files and folders. So I'm going to say copy everything again inside app. I'm only working with app. Okay. And then I'm going to say, once you do that, then run MVN clean. That's going to remove any target folder if I had any. And then after that, I'm going to say run MVN package, which we just saw, and then I'm going to skip all the tests because I don't have any tests. And I'm going to say skip test. Okay, so that's my first build. Once I do this, then what's going to happen is I'm going to have a jar file, okay, with all the other files as well, but also a jar file. At this point, then I need to get Java. So I'm going to say from open JDK, I think. JDK, and I want 17 and -JDK -Alpine. Okay, so that we can get a light version. And then I want to copy just the jar file from the build. So I'm gonna do dash dash from equal build, and then I have to specify what I'm looking for in the build. Remember, we put everything in app, and I want to go inside of the target slash whatever jar that I have. So whatever ends in jar, copy that, and I'm gonna copy it into a file called app.jar. Okay, and then after that, I want to expose 8080 because that's where my application is running. So 8080. Okay, and then after that, I'm gonna pass in the command to run, which is the CMD, and this takes an array. We want to call Java and then dash jar and then app.jar and then close this and then save. So that's what we have to do to create our image. And just to recap, I'm gonna go up and go over this one more time. First line is we're installing Maven because we need Maven to run all of these commands, right? So we're gonna get Maven version 3.8.6 and we're gonna define this as a build. So we're really giving the base image a name, which is build. Okay, so I came up with this name. You can give it any name you want. And then I define a folder called app because I want to work with this folder so that I can keep everything clean. And then I copy the POM file, as you can see here. Copy the POM file inside of the app folder that I just created. And then I run mvn dependency resolve. This is gonna work because on line 1, I have Maven installed. So that's going to run and it's going to read the POM file and then it's going to install all of the dependencies. That's all I'm doing. And the reason I'm doing it like this is because in your Docker file, you want to do things in stages because it's going to help with performance and caching. When you have things in stages, then if you rerun the same commands multiple times, it's not going to redo something that it already did because it's going to cache it. That's why you want to break it down into different stages. After that, I'm going to copy the rest of the files inside of the app folder. So once I have everything inside of the app folder, I'm going to run Maven clean, which is going to remove any old target folder that I might have had inside of my application. And then I'm going to run mvn package and skip all the tests on line 7. So after that's run, then I'm going to have a jar file that's going to be inside of the target folder, which I know that because I just ran mvn package. And then after that, I'm going to go and get a copy of Java. Okay, Java 17, a very light one, the Alpine version. And then I'm going to copy from the build just the jar file, which I know is going to be inside of the app/target. I just put an asterisk that jar because there's supposed to be only one jar file inside of the target folder. And then I'm going to name it app.jar. So that's the name that I'm going to give it. And then I'm going to open port 8080. Okay, that's what the expose is doing. And then I'm going to tell the container the command to run at the very end. It's going to run this command, which is java-jar app.jar. So that's our Docker file. So when we have it like this, what's going to happen is we're going to have an image that's just going to have Java, one jar file, and then we're just going to run that jar file. Okay, so I hope that makes sense. And I'm going to go out of this. And if I list everything now, you can see we have the Docker file. But now remember, if we run the application like this, it's going to fail. And the reason for this is because we have a database configuration. So if I go in the resources, open this, you can see we have a whole database configuration. So when the application is going to look for this, it's not going to find it because the Docker container is not going to have access to this IP address. So this whole thing is going to fail. So what we can do is to provide another container that's running MySQL, and then we're going to give the credentials to this configuration. And that's what I'm going to show you how to do next. So if you look down there, you can see we have the Docker file. Okay, so you can see it exactly the way that I just created it. Okay, so that's our Docker file that's going to allow us to create an image for the Java application, which is just going to run the jar. But in order to run multiple different services, which we need to do because we need to provide some of this configuration to the application, we need to use something called a Docker compose file. And that's what I'm going to show you how to do now. So let's go back to my terminal and I'm going to clear this. And then I'm going to open Vim again. And then I'm going to do docker-compose.yaml. Okay, that's the YAML file in this case. So inside of there, I'm going to go ahead and define some services. So that's the first line. Services, and then I'm going to define the MySQL service. So I'm going to call it MySQL DB, for example. So that's the name of the service. And then I need to define the container name. So I'm going to say container underscore name and I'm gonna call it MySQL container for app. Okay, whatever name you want to give it. And then I'm gonna define the image that we want for that particular container, and that's the MySQL version 8.0. Okay, so that's the image that we're gonna pull from the internet. And then I want to set a restart policy, which is gonna be unless stopped. Okay, so if the service stopped, oops, then go ahead and rerun it. And then I'm gonna define a command. This is to allow us to be able to authenticate using the default authentication plugin. So here I'm gonna pass in --default authentication plugin, and then I'm gonna set this equal to my SQL underscore native underscore password. Okay, and then I'm gonna define some volume. The volumes are like storage for whatever you have, and it's an array, so I'm gonna put a dash, and then I'm gonna say go to my home directory. So I'm gonna do -home in all uppercase, and then /database. So this is where I'm gonna store all of the database information that we're gonna have. And then I wanna point it to var library MySQL. And then, oops, I just want MySQL. All right, so that's it. And then we need to define the ports. So port mapping, so that's also an array. And I'm gonna say we want to map 3306 from the computer to 3306 from the container. And then we can also define the expose, so what port we want to expose. That also takes an array, and that's 3306 because that's where MySQL runs by default. And then now we can define some environment variable. So we're gonna say environment, and this is gonna be MySQL underscore database. So this is really important. We have to set the name to the same database that we have, which in this case is employee. And then let me see if I can copy this line, paste it a few times. We need the MySQL, that's gonna be the user. In this case, this is gonna be, let's say, admin. And then we need the password. I'm gonna change this again to let me in. And then we need the root password. I can just copy this and paste it and go here and then do root underscore password. I'm just gonna let this to let me in again, and I don't think I need this. And then I can define a service. I like to define this service tags, and I'm gonna do maybe prod. Okay, because let's imagine we're gonna deploy it to production. And then we have service underscore name. Now this is also really important. We're gonna name this MySQL DB. Okay, so that's that. So the service name is like a network name that we can use, that one here. It's a network name that we can use to pass to other services. So it's really important. And then lastly, we can define a network. So we're gonna say networks, and that's an array. The first one, I'm gonna say API network. Okay, so I'm just defining this name. And then at the bottom here, I'm gonna define this network. So here I'm gonna say networks and define the name that I just defined. So API network, and then give it a driver of bridge. That's the default, but I just like to specify it, and then save. Okay, so what we just did, as you can see here, is we're defining a number of services, and we're defining the first service, which is MySQL DB. We give the container, when the container spins up, we give it a name of MySQL container for app. We need the image, so we're gonna say we need the MySQL version 8.0, and I'm gonna remove relative line number again. And then on line 5, we say, hey, restart this container if it stopped. And then here we define a plugin for our password. Here we map some values, so whatever storage that this is gonna save, we're gonna save a copy of that on our local machine in a folder called database. We map the port on the local machine, so this is the port on the local machine, that one. We map it to 3306, which is that one that we're exposing. And then we define some environment variable. which is going to be the MySQL database, which is going to be the name of the database, which is employee, and then the MySQL user, which is admin. So we're just defining a new user, and then we're defining a password, which is let me in, defining a root password, which is the same, and then we define a service, which is prod. So that's just a tag, and then we give the service a name so that we can use it in networking, which is MySQL DB, which is similar to what we have on this line right here on line 2 up here. And then we define a network because we need to define this so that we can put both the MySQL and the Spring Boot application on the same network. So that's why we define this network here. So it's going to work for both the MySQL service, so the MySQL database, and also the Spring Boot application. Since they're going to be on the same network, then they're going to be able to talk to each other. So that's why we're defining the networks here. Really important. So we're going to save this again. So at this point, we can define the other service that we need inside of the Docker Compose file, which is going to be the service for the Spring Boot application. So that's what we're going to be working on next. Let's go ahead and see if we can add inside of the same Docker Compose file the service for the Spring Boot API, because we need to be able to run these two applications together. So let's go ahead and open the Docker Compose file again, and I'm going to go at the very top, and then I'm going to copy everything from the service all the way down to the network. So I'm going to copy all this, and then I'm going to come down to 22, and then I'm going to paste it. And I'm going to go down to the bottom of the file, add a space here, make sure this is all the way over there, put this in the middle. Okay, all right, so this is our network. So what we're going to do here is for the service name, so this name here, we're going to change this to API application or something like that. Oh, this is misspelled. Fix it. So API application is going to be the name of the service. And the name of the container, I can copy this and then change it here. Okay, so that's going to be API application container. So that's the name of the container. So whenever we run the container for this specific service, then that's the name it's going to have. And then here for the image, we need to build the Docker file that we have. So for this, we're going to say build and specify the current directory with a dot, which means that the image is coming from a Docker file and the Docker file is in the same directory. And then here we can give the image a name. So for this, I'm going to change everything here, and then I'm going to call it API application version 1. Okay, so we give it a version as well. We're going to do the same thing here for restart unless stop. We don't need this command. That was a MySQL thing. We don't need this volume either, so I'm going to delete this as well. The port, we're going to change this to 8080. We're mapping 8080, and we're going to change that as well. Okay, I'm going to paste this in here. So we're exposing 8080 and also mapping 8080. And for the environment variable, so we're gonna need something called spring underscore data source underscore URL. And I'm gonna copy this and paste it down a few times and get rid of these ones, these two. And here we need the URL. I think we need the username, so we're gonna say user. Oops, that's not what I meant to do. This is gonna be the username, and I'm going to change this to, I think we have to put this in a quote, so that's going to be the admin. Okay, so that's the user that we define. And here we need to define the data source, so that's going to be JDBC colon MySQL colon // the name of the service. In this case, I'm going to go up. If you remember, the name of the service that we define is MySQL DB. So this name right here. Okay, so it's the same name that we have for the service. So if we go up here, that's the same name. Okay, so we can either use that name that we define for the service, or we can use a service name, as you can see here. So I'm going to use the service name, which is the same. Well, it's not quite the same. So MySQL, so MySQL DB. Okay, so that's the name that we want. So I'm going to copy this, go down here and pass it here. Okay, and then of course the port is 3306, and then we need to pass in the name of the database. In our case, that's employee, and then save. And then here I'm gonna pass in the password, that's let me in, and then close that. And we need to change this for the password, so password, and we don't need all this. Delete, put this in the middle, save. And then there's another thing we need here. which is going to be depends on. So we're going to say depends underscore on, and then we need to pass in a list. So here we're going to pass in the same MySQL service. So let's go up here. This is what we need. Okay, we're going to copy this, paste it here, put a space here. Oh, this is supposed to go here. So we're technically saying that the service, which is this Spring Boot service, it depends on the MySQL service. So it's going to wait until the MySQL service is up and running, and then it's going to try to run this service. And then it's on the same network, so API networks, which is why we're able to do this. Oops. We're able to pass this, okay? Remember, we're passing in the name of the service right here. So that's why we're able to do this, because they're on the same network. So everything should work. If I don't have any typo, delete that last line, go to the top, save, container name. Just gonna do a quick rundown here. Okay, MySQL. Oops, I have a typo right here. So this is supposed to be MySQL. All right, save that. So container name. Okay, restart, volume, port, MySQL database, MySQL user, MySQL password, tag, network. Okay, so that looks good. And then we're gonna do the same here and move this over. So the name of the service, container name, the build is the Docker file. You can see we're specifying here. Then we have the name of the image, same policy, port mapping, and then the Spring data source configuration, and then the tag, the service name, we can change that. We can rename this to something like Spring API. So that's good. And then it depends on the MySQL DB service, and then the network is the same. All right, so that looks good. So I think we should be in good shape. And what I'm gonna do after that is to just run these services and then deploy them on my server on my network. But you can deploy this anywhere that you have any server running. And I'm gonna talk a little bit more about that as well. So that's what we're gonna be doing next. We're gonna be trying to deploy this and see all of this hard work in action. So let's go ahead and see if we can deploy this application. So I'm going to get out of here and then go to the first workspace. And what's going to happen is with this configuration is it's going to override this information. Okay, so, and we don't have to change anything here. It's just going to override it whenever we run the containers. And you can also pass other configuration as well. So under the environment, let's go back in here just so I can show you. So under there, like this environment here, you can pass in whatever you want to pass, and it will be picked up by Spring. Okay, so however you want to use it in your application, that's a different story, but you can pass environment variables to your application very easily. We're gonna need to deploy this, and I'm gonna go back to the second workspace and get out of here. Okay, so if I do Docker on this computer, you can see you can't find it, but if I SSH inside of this computer that I have and put in my password, if I can type it correctly, nope, let's try that again. All right. So if I go in here and type Docker, then you can see that I have a response because Docker is installed on that computer that I have on my network. So let's get out of here, and I'm gonna step back a little, and I'm gonna copy everything inside of this file over to this computer. And to do this, I'm gonna do SCP, since it's a folder, do Control-R for recursively, pass in the name, and then I say I'm gonna copy it over to Vostros, which is the name of the computer. I set up this name, by the way. And then I want to go to the home folder and copy all of this over there. I'm going to press enter, ask me for my password. I'm going to put my password, and then it's going to copy all the files. Taking some time. Okay, so all the files have been copied, and I'm going to go back in there. Well, I don't need to go back in there. I just need to SSH inside of this other application, and then password one more time, go inside of the folder that I just copied over, and I can list everything. You can see everything is in there. You see the color is different because I'm logged into a different computer. Now I'm gonna do some cleanup. I'm gonna remove the class and that factory, that IDE, that MVN. I don't even need the MVN, that project, and that settings, mvnw.cmd, and also the target folder. I don't need these. Okay, clean up, list everything. Oh, I hate the help as well. I don't need that. List everything. Okay, so we have the source file, the Docker file, the Docker compose, and then the POM file, and then the source of all of our source code. Okay, so now to deploy this on my network in this computer where I have Docker running, I can just do Docker, Docker compose up -d for detached, and then I want to do -- build so that we can build the Docker file that we have inside of the compose. Because the compose is making a reference to the Docker file with the dot, then we have to pass in the -- build. And then I'm going to press enter, and hopefully we don't get any errors. So let's play this on. Okay, so we get an error in the compose file. So let's go ahead and open that up, Docker compose. And it says it's supposed to be in the depends on. Oh, it's under environment. That's why. So let's move all of this out. Okay. Okay, so they're not supposed to be under environment. They were a little bit under environment. And this is a YAML file, so indentation is really important. All right, let's give this another try. Okay, let's see what we have here. And we have a mistaken volume. That's supposed to be volumes with an S. So let's save that. And now let's try that. Okay, seems to be working. Let's see what's happening. All right. Let's give it a couple minutes. Okay, so it's downloading all the dependencies. So it's running the MVM resolve. So that's a dependency resolve. It's getting all the jar files. Okay, build success. That looks good. Copies everything inside the app folder. Build success again for the Maven clean. Now it's running the Maven package to generate the jar file. That is also a success. Okay, so now it's getting the OpenJDK, copying the jar file. Let's clear the screen and let's do Docker yes. So it looks like it fails. Oh, invalid restart policy unless stopped. Let's see if we can check this out one more time. So we have unless stop, and we have a typo here, so that's supposed to be unless stop. Okay, so I'm gonna do stop and save it, go up here and make the same change. So stopped. Okay, so let's quit out of this and let's do this one more time. So run. You can see it's using cache for a lot of these stages, and now it's going to be a lot faster. And let's give it a couple more minutes. Okay, this time it looks like it works just fine. Now I'm going to look at all the containers again. Okay, so now everything is working. So you can see I have 2 additional containers that I didn't want to stop for this tutorial because I have processes running. But you can see we have the MySQL container for app, which is running, and also API application container. So we have the 2 containers running. Another thing we can do is to look at the logs. So we can see docker.logs, and then we say API application container. We just give the name of the container, and it looks like it failed after the application started, and it's saying that it doesn't have access for admin. Now there is some other stuff we can do for this. So let me just do one thing real quick. So I'm gonna do docker -compose down. Okay, that's gonna destroy everything that we just did so that we can start over. So let's give it a couple minutes. Okay, so it removes everything, and then I'm gonna go back in the docker compose file, and I want to go down there, and instead of passing in the admin, as you can see that I'm doing here, I'm gonna pass in the root. So I'm gonna change word, pass in the root. Okay, so because the root is gonna have all the different permissions, and I would have to change permission on the admin so that we don't have this error anymore, but I don't wanna have to do that. So I'm gonna save this and then run it again one more time. So Docker compose up, and let's see what happens this time. Okay, looks like everything looks good. Let's go and check the logs again. This time everything is working. So you can see the application started on 8080. So now we can access it using the IP address of this machine. So just to show you guys the IP address of this machine, I'm gonna show you what that is. So that is this IP right here. So 192.168.1.2.16, and those are the IPs coming from the Docker engine that I have running on the computer. But this one is the one that we're looking for. So 192.168.1.2.16. And then I'm gonna open the third workspace and see if I can access Postman again. And then we're gonna send a request. So instead of localhost, we're going to change it to this IP address and send. That should give us a 200 because we have the authorization. Okay, so we get the users. If we remove no auth, okay, unauthorized. So that's looking good. Send. Let's see if we can create a new user. So go to API accounts, post request, and let's do junior 2 with the same password. Save. Well, we have to change the URL. So that's 216. Send, and then we get an error. So let's see what happens here. So scroll up. So query did not return a unique result. So I think I know what's happening here. It's because we have multiple different user and admin roles in the database. So let me move this over here. So I opened this, as you can see here, and you can see we have all of these different admins and users. So when we try to save a new user, then it finds 2 users and 2 admins. So it doesn't know which one to choose. So MySQL threw an exception. So I'm gonna delete all these and just leave the 1 user and then 1 admin. So now if I just move this over here and send this request again, now it works, okay? Because it wasn't confused with the role user. So we're able to create a new user, which is junior 2, and I can use this user here to create a new employee here. Let's do maybe Joseph or 8, and then we're gonna pass in my authentication. So that's junior 2. And then send. Oops, we need to change this to 192.168.1.2.16 and then send it. Oops, the IP address is incorrect. So 192.168.1.2.16. So let's send that again, and you can see it's created. So the application is deployed, but it's deployed on my local network, and that's where we're testing it right now. Okay, so I can create a new account. I can, let's see if we can get a list of all of the accounts. So duplicate this, send a GET request, and then send unauthorized, authorization, basic auth. I'm gonna try junior 2, send, and then here's all the users. So we have like 2 users. Okay, so junior and then junior 2. So the application is deployed and it's working exactly as expected.
What I would like to show you now is how to manage access to your application using the roles that we gave the users. So if I go inside of the security configuration, you can see here we're defining these 2 roles that we're allowing to access the application. But we haven't defined anything else other than saying that anybody with these roles can access all the endpoints on the application. So what I'm going to show you is how you can restrict certain users to certain endpoints or to certain access. And this is why we define this enable global method security pre-post enable to true online 17 here. So now we're going to make use of this annotation that we added here. But before I do that, I just want to clean up this configuration a little bit. There's like many different ways you can write this configuration that's a little bit fancier or newer ways of doing it. It's still going to be doing the same thing. It's just going to look a little different. So I'm just going to clean this up a little. Here, I'm going to do it like this. And then going to pass in the int matchers. Going to put this on the new line. I'm going to add another int matchers after that one. So I'm going to go down here. Going to delete this. Gonna do that int matchers again, and I want to say for everything else, so I'm gonna remove the method and pass into asterisk here just like that. So for everything else, we want to have it authenticated. We don't need this line here. Okay, and then I'm gonna move this over here. So for everything else, we're gonna authenticate, and then we're specifying the roles that they should have, and then HTTP basic, stateless for the session management, and then we're gonna return the build of this. So this is just a little bit cleaner in my opinion. So one annotation that we can use to manage access to the resources is gonna be the pre-authorized annotation, and I'm gonna show you that real quick. So if I go inside of the let's go inside of the employees, for example, and in here let's say on the post request, so whenever we're gonna create a new employee here, I'm gonna add a new annotation. So I'm gonna say add, and that's gonna be the pre-authorized. Okay, and then in here I'm gonna say if anyone is gonna access this, they need to have the role of admin. So I'm gonna say as role, and then in here I'm gonna pass in the role that I want them to have, and then here I'm gonna pass in admin. Okay, so that's gonna check to make sure that the user has the role admin before executing this method. Otherwise, they're gonna get a forbidden, meaning that they don't have access to do this. And there's also another one called post-authorized. I think I don't use it very often. I usually use the pre-authorized more, but this one is gonna check whatever condition you put in here after it executes the method. But for the pre-authorized, it's gonna check the condition in here before it runs the method. So we're technically saying, hey, for someone to be able to send a request to this endpoint, so to the API/employees, but the post request, they need to have the role admin. Okay, so that's what we're saying here. And I'm gonna stop and rerun the application. And another thing I'm gonna do, I think if we go inside of the database right now and we go into the account and run this, so we have two users in here, junior and junior 2, and their IDs are 7 and 22. And if we go inside of the account role and we run that as well, so they have the role ID 5. And if we go inside of the role, we run that, you will see that role ID 5 means that they're both users. Okay, so they have the role user. So I'm gonna make one of them an admin. So I'm gonna go back here and maybe I'm gonna take junior 2 with ID 22, and I need to give it the role number 6. So let's go to the account role, and then instead of 5, I'm gonna change this to a 6, and then I'm gonna save it. I'm just doing that manually, but you can do it in the code as well. And we run that. You can see now role ID 6 is assigned to account ID 22, and account ID 22 is junior 2. So at this point, only junior 2 should be able to send a post request to save a new employee. So let's check to make sure the application is running. Okay, so application started on 8080. So now I'm gonna go back to the Postman. We're gonna send a post request to employees. And remember, whoever is gonna send a post request to employees, they need to have the role of admin. So let's see what user we're passing in here. So here we're passing in junior. So junior has permission over user. He has role user. So if I send this request, it should give me a forbidden. So let's go ahead and try this out. And you can see here we have 403 forbidden. That means I can access the application like I'm authenticated, but I don't have enough permission to access the particular resource on the server. However, if I change this to junior 2 has the admin permission or admin role, and then I send the request again, you can see this time I'm able to create the new user. This is one way that you can manage access to resources using the roles. And another thing I want to bring to your attention is how you define these names. You see here, whenever I'm inside of the security configuration, I'm only passing in user and admin. And then here, I'm passing in admin. So I don't put the role underscore. And in the database, we have actually role and then underscore as the name of the role. But that's because Spring Security is going to add a role underscore in front of this automatically. So you don't have to add it again. So always keep that in mind. Otherwise, the application is going to break because Spring is going to add the role underscore in front of the role names. And you can also do the same configuration inside of the main security configuration. So in here, you can put other int matchers and then you say has role and then you specify the role. But here I'm doing it for the entire configuration, but you can do that on specific URLs or a specific path in the application. And usually what I do is I have some that I put inside of the configuration. So I put some of these configurations to manage access to the application in here, maybe some generic ones. And then the ones that are more specific, I use the pre-authorized and then I pass in the role that I'm expecting at the method level. So I just wanted to show you how we can use the roles that we assign and manage the access to the application using these roles, because we actually created all the configurations for it, passing in these roles here, and then also adding this annotation, enable global method security. And one last thing I want you to test You see here, we're saying anybody accessing the application, they should have user and admin roles. So for example, if you go inside of the database and you insert a role here, maybe like manually, let's say role manager, and then you assign these roles to these users. After you do that, if you come back here and send a request, it's going to give you the same forbidden because this role is not one of the roles that we define in the security, as you can see here. But you can go ahead and test this out. It should work the same way that I just tested. So I hope that makes sense. And if you have any questions, go ahead and reach out to me. But this is something that you're probably going to want to do in your application, because that's the reason why you're specifying different roles and different permissions, because you want to give different access to different users inside of your application.